Hello, and welcome to 5 Minute Math. Today we are looking at the Algebra I STAAR EOC from 2024. You can follow along with a custom statewide item analysis report that I created using the tiny URL or the QR code you see on the screen. We're going to walk through all 50 problems, but if you ever want to jump ahead, you could use any of these timestamps you see here, or they are also bookmarks or chapter marks at the bottom of the screen. For number one, we are looking at standard A.11a. We are simplifying square roots, and it's a pretty straightforward problem to get started with on this STAAR exam. We need to find an expression that is equivalent to 7 and then root 45. And so we're going to leave this 7 alone. Really, let's look at that root 45. And what we're looking for factors that can multiply into 45 that are perfect squares, right? So we know our perfect squares are 1, and then 4, and then 9, and then 16, and then 25, 36, and then we're past it. But hopefully we saw right there, we can hit that 9. So let's think of 7 root 45 as, and then let's go ahead and just kind of factor this out. We're going to do this times root 9, because that's where that's from, and then 9 times what makes your 45, right? So that's going to be 9 times 5. Okay, so what I'm using here is the commutative property, right? I'm just kind of, or the associative property, I'm really just kind of splitting this apart, grouping this slightly differently. That's where my square root of 45 was. That square root of 9 times square root of 9. You can combine those to make a square root of 45. But now that I've separated them using the associative property, that on its own doesn't have to be square root of 9. That can be 3, because square root of 9 is 3. So now let's think about it like this. So square root of 5 times 7 times 3, that's 21. And that's going to be 21 square root 5. So that is going to be my answer. And if we are unsure, I would highly suggest let's opening up our calculator here. And let's just plug them in. 7 square root 45. All right. And then let's do 21 square root of 5. And you notice we get the exact same. So if we get stuck, we can obviously plug them into the calculator. And so our answer here is D. Now, how did we do? Well, 81% of our students got this. That is a fantastic number. In fact, this is the first easiest item on the test. So it only gets more difficult from here. But our students did fairly well, and the rest of these numbers are what I like to consider statistical noise, right? If you're getting below 10%, you're getting really close to just guessing and just random chance there. Anytime we get above 60%, we're feeling pretty good about that particular item. So 81% is fantastic, and we should feel pleased with that one. For number 2, we are looking at solutions graphs and quadratic functions. This is standard 8.6c. And we got a little bit of work to do on this one. So we have a graph, and we need to find the function that is best represented by the graph. Now, once again, we have a calculator. We can open up the TI-84, we can open up Desmos, and we can graph each of these, and we can find which one matches it. And if we know anything about graphs, we should know that we can eliminate 2 answers right now. I can eliminate those 2 simply because those 2 have a positive value in front of that leading variable, right? That leading coefficient is a positive 1. It's hidden because it's not there, but it's a positive 1. This is a negative graph because it opens down. So when you have a quadratic that opens down, it's negative. So which means I'm kind of stuck between these 2, and you notice the only difference is right here. So if, like I said, if we wanted to, we can graph these, but we don't have to graph these, okay? So let's first identify our zeros. What are our solutions? Okay, well, I've got a negative 5, so I'm going to put my zeros at negative 5 and negative 3. Those are the 2 places that my graph crosses my x-axis. Now, if I'm thinking about one of the forms that we have here, right, we've got f of x Actually, it's going to be, let's just think of it like this. F of x equals, we've got a, we've got some type of multiplier out there, right? And then if we're looking at it with our zeros, it's x minus u and then x minus v. This is how we can take our zeros and we can put them into a factored form. Now, if I want to get my u as -5, I can make my v -3. So it's going to look like this now. F of x equals a x minus, now I've got to keep that negative in there, so x minus -5, x minus -3, which of course simplifies to just a. Still not sure what my multiplier is going to be. And that's going to be x plus 5, x plus 3. Now, I still have a lot of variables. I'm trying to figure out what this a is. Not sure what that is. So let's take a point. Let's take the vertex here. So my vertex is going to be -4, 1. And let's plug that in. And that should give me everything. All right, so my f of x is going to serve as my y. So that's going to be 1 equals a. And then my x is -4. And my x is -4. All right, so now we can simplify. 1 equals a times -4 plus 5 is 1. -4 plus 3 is -1. So a plus, or a times 1 times -1 is going to be 1 equals -a. I don't want a negative a, so I'm going to just multiply both sides by -1. I want a positive a, and guess what I get? A equals -1. So I don't really need that -1, but I just can't leave it. I can leave it as a negative. So that's how we know right here that we've got that negative right there. And then if we want to figure out whether it's that -8 or that +8, well, we can go back to this right here. And let's just factor this out, right? So let's use FOIL. So I'm going to do x plus 5, x plus 3. I'm just looking at that part right there. And that's going to be x squared plus 3x plus 5x plus 15, x squared plus 8x plus 15. And then we already figured out my a is -1. So I need to make that negative x squared plus 8x plus 15. Now, this negative, you notice my negative right here is actually an outside variable. It goes across everything. So what I need to do here is, rather than simply making my x squared negative, though this negative x squared tells me it's a downward facing, I actually need to multiply it by everything. So if I need to factor out this -1 right here, so that's a -1. So I need to distribute that. It's going to be negative x squared. It's going to be minus 8x, and it's going to be at minus 15 because we distribute that out. Now we've done all of our work, and we are ready to look at our answer, and that is A. So how did we do? Well, we did okay. We did 77% of our students got that correct, so we should be very pleased with that, 77%. Once again, that is above our 60% threshold, so we're feeling pretty good. We had 11% of our students choose B. We had 7% of our students choose C, and then 4% of our students choose D. So I showed you how to figure that out mathematically. Once again, if you have a calculator, you can plug this in 4 different times, and you can find the one that matches. That also works for this problem, as long as they give you 4 answer choices to choose from. Our students also need to know how to do it without selecting from 4 possible answer choices. So this is our third easiest item on the test. For number 3, we are looking at direct variation. This is standard A.2b. And we've got a drag and drop. So this is a 2-point item. We need 1 correct answer in each one. And each answer might be used more than once, or they might not be used at all. So we have y varies directly with x. Now that tells us quite a bit. Let's go to our reference material, see if we have anything here for us when we're looking at direct variation. And so we'll notice that we don't necessarily have direct variation. That has kind of shown up for us in middle school, 7th grade, 8th grade. But what we should know is that we're not looking at that slope-intercept form. This is a linear equation, but when we are thinking of direct variation, y varies directly with x. Typically, we will represent it like this, y equals kx. And so the difference here is that we're not looking at y equals mx plus b, because that doesn't vary directly. That's not proportional, because it's this b that messes everything up, that pushes the linear graph up or down on the y-intercept. Y equals kx goes straight to the origin. It is proportional. So when the value of x is 4, the value of y is negative 12. Okay, well, let's plug that in. So if x equals 4, y is going to equal y is going to equal negative 12. So we've got that. All right, so let's figure out what is k. Well, just divide both sides by 4. It looks like my k is going to equal negative 3. Okay, so that's my constant of variation. That k is used to represent that. We can also think of that as our slope if we need to. That's it right there. So now if I go back to my original, y equals negative 3x, because negative 3 is my constant of variation. What is the value of y when x equals negative 6? Okay, so I'm just going to say y equals negative 3 times negative 6. That's going to equal positive 18. So there we go. That is, my answer is going to be negative 3 and 18. Now, if you know what you're doing, that's fairly straightforward. We're literally just dividing negative 12 by 4 and multiplying negative 6 by negative 3. But you notice there was nothing on the reference materials for this. Students had to know this coming in. This y equals kx had to be something that they associated with direct variation. And if they didn't, they struggled. And in fact, our students definitely struggled. Okay, we had only 26% of our students get both items correct. We had 27% of our students get one item correct. We don't know which of the two items they got correct. We don't get that level of data from the state. We had 47% get nothing correct. So that's almost half of our students were unable to access this completely. Now, when we're looking at percent correct, what we do is we take about half of the 1, add that to the 2, and you get about 40% correct. So now we're down to earth again, and that is a very difficult problem. In fact, this is tied for our 11th most difficult item on the test. So that was difficult, but it's a simple vocabulary thing. If we can help them realize that when we're saying that y varies directly with x, that equals this, that k is my constant of proportionality, which is a term that we really focused on in 7th grade. We have to bring that up with us into 8th grade. Well, then that becomes a very straightforward and simple problem. So next, for number 4, we are looking at attributes of quadratic function graphs. This is standard 8.7a. And we've got some graphs here that we're going to need to scroll down for, and that's fine here. So we're looking for a quadratic function that has no real zeros. Okay, so let's just label these over here. Now, what does that mean, no real zeros? Okay, so zeros are also called solutions. And they're also called, and this is the one that really helps us, x-intercepts. So when we're talking about a zero, we're talking about a quadratic function, and we're talking about if x equals 0, what is our, when y equals 0, what is our x value? And so we're looking for x-intercepts. And so look at A. No x-intercepts, because you have a quadratic function graph that opens up and its vertex is at positive 2 and on the y-axis, so it's never going to reach below that. So A looks like it could be the correct answer. Look at B. B has got 1, 0, okay, one solution, and it's going to be at 3. So if I wanted to really list that, I would say 3, comma 0, because the solution, remember, or zeros, what is the value of x when y equals 0? So I'm looking at C. C is a more traditional, it's got two zeros. Okay, so it's going to have a 0 at -1, and it's going to have a 0 at 1. And then look at D. That is a vanilla quadratic function, y equals x squared, and you have 1, 0, and it is at the origin, but that is a 0, that is a solution. So you notice we only have one that has none of them, and the answer is A. Now, how did we do across the state of Texas? Well, we did decently, not as well as we would hope that we would. We had 59% of our students choose A, so we're not quite at that 60% threshold, but we're extremely close. Now, we did have 18% of our students choose B. That was the most chosen incorrect item. So let's take a look at B and see what messed them up. Well, there's no visible y-intercept on B. So if for some reason you thought a 0 meant when it crosses the y-axis, well, then that's the only one that doesn't visibly cross the y-axis. Now, if we extend, we know that it's going to cross right up here somewhere. But on what we have zoomed in on this particular graph that only goes to 6 and -6 on both axes, it doesn't have a visible y-intercept. So this could be an opportunity to work with some of our students. There's 18% of them that might have thought the 0 was where it crosses the y-axis and not the x-axis. That is a misconception that we can deal with. But other than that, our students, for the most part, did pretty well. In fact, this is the 19th easiest, or tied for the 19th easiest. So it lands a little bit on the easier side. A 50-point test, that's not too horrible, getting close to that 60% threshold. Next, for number 5, we are interpreting exponential functions. This is 8.9b. And we've got a problem situation here, and they actually give us this function. They give it to us. So this is, hopefully we recognize this, compounded annually. And so this is compound interest. So let's see, do we have anything here on for compounding interest? And you'll notice we have quadratics, we have linears, we have powers of exponents. We don't have anything on that, and that's because we've introduced compound interest for several years. So at this point, we're expecting students to know what the formula is. Okay? And so what we have here is the compound interest. I'm going to put it right here. Compound interest is a b to the x. Now, we need to know what these three are, because if we know what these three are, then we're going to be able to describe this. But that's this whole standard, is to be able to interpret this, okay? So this a in this a position is already always your principal amount. Principal or your initial amount. It kind of depends on the context of the problem, but it's how much money you're investing, is whatever that A is. So in this case, we're investing $1,550. Okay. This B is always your rate. Now, this is an exponential function in which we are investing money, which means the rate is positive, right? Sometimes you get a decay rate. This happens to be a growth rate because it's not only is it positive, it's greater than 1. It's a decay rate if it is less than 1. And then this x is always going to be your time. Typically years, but sometimes the problem situation might call for it to be days. So let's look at this. The initial deposit in the investment was 1581. And no, that's not. This is going to be the value after 1 year, but the initial deposit is 1550. So A is incorrect. The amount of money in the investment account increases 102%. Oof. That would be interesting if it increased 102% each year. That would be very nice. Now, even though this looks like a 1.02, you have to subtract the initial 1 to get the actual rate, right? Because that 1 holds the value of the initial deposit. And so really, it's a 2% increase. right? That 100 or that 1.02 is what keeps the value of the initial deposit. But you have to subtract the 1 to get the rate, and it's 0.02 or 2% interest. 102% interest is crazy. And you'd make a lot of money, and the bank would be out of money in about 2 seconds. Now, C, the initial deposit investment was 1550. There we go. We've said that multiple times. That is our correct answer. Let's just look at D to make sure it is incorrect. The amount of money in the investment account decreases. Okay, so it is a 2% rate, but you see how that says decreases? It's increases. So they interpreted incorrectly. A decrease of 2% would actually look like this, 0.98. It would be 2% away from 1, because that 1 is that standard. If you multiply by 1, right, nothing changes. So that's incorrect as well. Our answer here is C. So not really a lot of calculation, is more interpretation. And we got 61% of our students that got that correct. So it's not as much as that 80 that we had earlier, but that's pretty good. We had 19% of our students choose B. That was the most chosen incorrect answer. And it was because they misinterpreted that 1.02 as 102%. And if if you want to just look at it as straight decimals and percents, I mean, that is correct, right? If I just look at 1 and 200ths and transform that into a percent, it would be correct, 102%. But that's not how we're dealing with exponential functions. That 2% we have to interpret as how much above or below 1 as the standard rather than 0 as the standard. So that's where it gets super tricky. We had 12%, choose A, right? And they just went ahead and did the calculation, and that was at x equals 1 rather than x equals 0. And then we saw 9%. Not many students chose that because they saw that it was increasing rather than decreasing. So this was pretty easy. In fact, this was tied for our 15th easiest item on the test. For number 6, we are looking at laws of exponents. This is standard A.11b. And we've got to find an equivalent expression to this big one right here. And what we need to think of here, and we'll go ahead and keep it open since it is part of our reference material, is our properties of exponents. So when we're thinking of our properties of exponents here, what we need to do is we need to use a little bit of PEMDAS to figure out what we're doing first. And honestly, hopefully that first thing we're thinking is if we're looking at our PEMDAS for our order of operations, that exponent is what we need to deal with first. So I'm going to recopy this down. But what I want to do is I want to distribute this to the squared out to each of these terms, because that's one way you can think of it. So 6 squared, and this is x squared squared, and then this is y squared. All right. And then I could go ahead, there's nothing being multiplied by any of those terms inside that last one, so I could just go ahead and keep all those separate, right? I can just think of 2x cubed and then y to the fourth. I can go ahead and just take those parentheses off. So let's deal with all of these squared here, okay? So 6 squared is going to be 36. X squared squared. Well, what that is that is a power of a power. So that's going to be that third one right there. So if you have am and then taken to the n squared, you end up multiplying the two exponents, right? So a to the m, and then you take it to the n power, that equals, multiply both of those. So I need to multiply 2 times 2. I could have added 2 times 2. It still would have ended up with the same thing, but technically we're multiplying the 2. That's now x to the fourth. This is simply y squared. I've still got my 2x cubed, my y to the fourth. Okay, so now I'm looking at bases. I can go ahead and just simplify these two. 1/3 of 36 is 12. And let's look at my bases. I'm going to put my x to the fourth right there, and I'm going to put my 2x cubed together. I need to do something with those. And then I've got my y squared and my y to the fourth. I need to do something with those. And I've got this coefficient just standing right there, that 2 and 12. I'm going to bring those together and just multiply those to 24. So now I've just got an x to the fourth, x to the third. What do I do with those two? Well, that's the product of powers. That's this one up here. So that says if you have a to the m times a to the n, so two of the same bases, you end up adding your two exponents. So this is going to be, remember, that's just x to the fourth and x to the third. This is x to the 4 plus 3, or 7. Then I've got the same product of powers here, y to the second, y to the fourth, it's y to the 2 plus 4. That's going to be 6. So I've got 24, x to the seventh, y to the sixth, and that is a correct answer of B. Now, this required quite a bit of not only PEMDAS, but laws of exponents here. And so it really confused some of our students. In fact, we only got 39% of our students to get this correct. We didn't even crack 40%. And when we're looking at our other answers here, we got 25 here. We've got 23 here. And then we've got 13 here. Really, what that lets me know is we're not necessarily dealing with a misconception. There's just an awful lot of guessing that's happening here. And because that's about 25%, that's about 25%. And there's probably a significant portion of this 39% that got it right that actually guessed. Now, they had a good guess, but they probably weren't able to 100% know what was going on. And it seemed like the big issue here, look, you see how that's got that coefficient of 24. Not a lot of people chose the other coefficient of 24, right? How did we get that 24? Well, we had to take this squared initially, and we had to square the 36. And a lot of people probably didn't do that. They might have multiplied the 6 by 2 or just left the 6 all by itself, right? But when you're taking this squared, you have to apply it to not only the coefficients, but the variables as well. So you had to get that 6 up to 36, then take a third of it, and then double it. So I think that might have messed up some students. They were thinking that squared only applies to the variables, but it applies to everything inside the parentheses. This was difficult. In fact, this was the 10th most difficult item on the test. So that definitely provides other opportunities for us as educators to provide experiences for our students so that they have all of those, including when you have an exponent outside of a complex term like the 6x squared y. For number 7, we are looking at rate of change. This is standard A.3b, and we have just a basic statement here, and we need a graph that of a line that's representing. We could graph this if we want to, but it's not really asking us to graph it. Look, it's asking for the value that represents the rate of change of y with respect to x. Now, that is a strange way of asking it. It's very formal mathematical language, but we've got a rate here, right? So let's think of a ratio. So when we think of a rate, right, we're typically thinking of two different terms being compared to each other with division. And we can view it as a ratio. So we have a y with respect to x. Okay, so that means what I want to do is I want to figure out what is y with respect to x. Now, what do we know that also represents the rate of y over x? Well, that is our m. So really, this is a roundabout way of asking for our slope. Okay, so this is our standard form. So if we were to change this into our slope-intercept form, what we could do is we could just take that coefficient in front of the x. But this is just a real roundabout way of asking, and that vocabulary might have messed some of our students up. So let's solve for y so we get it into slope-intercept form. So what I want to do is I want to get that y on its own. So first, you know what? Since if I take that 5x over to the right side, I'm going to have a negative 8. So I'm going to do that just realizing that I'm going to need to probably divide by negative to make that y a positive. So that's going to get rid of that. I'm going to get negative 8y equals negative 5x. That's going to be a plus 40 because we're at a positive 40. Now I need to divide by negative 8. So that's going to be y equals, those two negatives make a positive, and that's going to be very important because look at 5 and 8 are all of my answers, right? and then that's going to end up being minus 5 if I needed that y-intercept. So there is the change of y with respect to x. That's our slope. But we need to know that that is one way to describe the slope is the rate of change of y with respect to x. So the answer here is C. And as you can guess, if you didn't really know what you're doing, then you were probably just guessing. And we got above guessing. We had 43% of our students get that correct. They were solving that standard form for slope-intercept form. But we had a lot of students choose B also. And, that you could get that if you add 5x to the right side rather than subtracting 5x. So this doesn't necessarily become a negative 5x. You keep this as a positive 5x. Then that becomes a negative 5 over 8. So it could have been a simple algebraic, mistake like that of isolating the variable. And we've got 17% on A, and then we had 9% on D. So this was definitely on the harder side. This was the 16th hardest item. I really do think the biggest challenge here was trying to figure out what in the world is this talking about. And if you just say, well, what's the slope? Our students probably can convert from the standard form to the slope-intercept form and pick out your slope really quickly. It's just a matter of recognizing that's what this problem is asking for. For number 8, we are looking at writing recursive sequences. This is A.12d. Now, when we're looking at the sequence, we've got the first 5 terms. Unfortunately, if we're looking for the nth term in the sequence, we're not going to find the standard form or the formula in our reference materials. So we need to know what this is. So when we're looking for the nth term of a sequence like this, right, we view it like this. A to the n, which is what we're dealing with here, equals, we need to know a few different things. We need to know what that first term is. Well, we've got that first term of 47. So we can go ahead and replace that. So 47. And then what we do is we add, and we're going to call it n minus 1 because what that means is that just gives us that next term. So what do we have to do to get to that next term, n minus 1? Well, we have to multiply it by our difference. So what is the difference? Well, let's take a look at our numbers here from 47 to 33. What's the difference there? Well, the difference is 14. The number's getting larger, smaller. They're getting smaller, so it's a minus 14. And with these types of sequences, it's going to be the exact same difference. Minus 14. Minus 14. Even to negative 9. 5 to negative 9 is a minus 14. Okay? So then we can substitute that in here. N minus 1. And then we're going to multiply all of that by negative 14. So let's distribute this out here. And we'll say a to the n equals 47 plus, right? And then I've got a negative 14n. And then I've got a minus, then I've got a negative 14, and then multiply that by 1. So if we get rid of all these pluses and minuses, we end up with a to the n equals, I'm going to go ahead and bring this negative 14 up to the front. It's going to be negative 14n. And then what I have here is a minus minus that ends up being a plus 14, right? Plus 14 times 1. So I end up with a 47 plus a 14. So that ends up with a plus 61. So that could get us our next term, right? So a to the n equals, 14 times that n, negative 14 times that n. So let's just plug this in just to make sure we got this right. A to the 4. Okay, so let's say a to the 4 equals negative 14 times that 4 plus 61, right? And so what is negative 14 times 4? That's going to be negative, let's see, that's going to be 28. That's going to be negative 56 plus 61, and that equals 5. And that is what it equals. All right, so that verifies our work. So this is what we need to plug in here. So we're looking for this negative 14, and then it's a plus 61. So once we set up the equation, we can just simplify it algebraically, but the hard part is remembering this right here. This is a 2-point problem, and so we get percentage of full full points would be 13%. 13% of our students got both of those correct. We had 23% get one correct, which means 64%. So almost 2/3 of our students had nothing. They couldn't even guess one out of the two correct. So this is our second hardest item on the entire test. If we're looking at our percent correct, what we do is we take, half of the 1 point and we add that. And so we're looking at, 12 and 15 and that 13. We're looking at about 25% correct, really, is what we're looking at. Hardest or second hardest item on the test. And so this is one in which we definitely need to spend a little bit of time. And it's this formula, for lack of a better term, that we need our students to really focus in on. If we could just remember this when we're dealing with recursive sequences, we can start plugging and playing the numbers. But that is definitely a difficult one for students, A.12d. Next, for number 9, we are looking at quadratic domain and range. This is A.6a. And we are just simply looking for the range of this function. All right, so let's graph this function and let's take a look at it. For this one, we can use Desmos, though if you want, it's possible to do it on the TIA4 as well. So let's just plug this in. So we are going to have a negative x squared, and let's just make it y equals. We could do f of x if we need to, but it's going to serve the same purpose. X squared, so there's my parabola. Notice the negative leading coefficient, that implied -1, makes it turn downward. So a negative x squared, negative anything x squared is going to make the parabola open downward. And then I've got a plus 60x. All right, so it's off the screen here. I'm looking for the range, right? So the range is the values of y. Those are the output values or the dependent values. And I'm still off the screen. So there we go. Okay, so it's way up there. So I'm looking for this maximum value, and it's going to be a nice, clean 3,900. All right, so my y value is 900. The range is this set of y values, so anything below 900 is going to work. Because you see, it opens up and it just continues, obviously, down forever. It expands forever, but we've got that maximum value of 900 right there, since we're looking for the range. So let's get that 900. All right, well, then that's going to be it then. So we can say that we need, let's get that back open. Y is going to be less than or equal to, what did we say our maximum value was? 900, right? It ended up kind of being like this. And that was 30 and then 900. So we're looking at that y value. So when we're looking at our options here, right, we've got 900 twice, but you notice one of them says greater than or equal to, one of them says less than or equal to. Obviously, we're looking at less than or equal to. So I wrote it with symbols. We need to describe it with words. All real numbers less than or equal to 900 is our answer, D. Now, this ended up being very difficult for some reason. Only 34% of our students got this correct. That's extremely low. But take a look at B. B had 44%. So we had 10% more students choose B. All real numbers that are greater than or equal to 0 and less than or equal to 60. Where in the world is 0 and 60 coming from? Well, let's open up our calculator back again. And let's look for 0 and 60. And what we're going to find here is those. So it goes through the origin right there, 0, 0. And it goes through 60, 0. Those are the x-intercepts. So for some reason, we had a group of students that thought that the x-intercepts meant the range. So that's a confusion for me. What typically happens is we're going to confuse the domain and the range, which probably is going to serve as that because you don't have any bounds on the x values, right? It's all real numbers because it's going to expand forever. But maybe they were looking for the domain rather than the range, and so they just noticed where it crossed the x-axis, and that was it. But for some reason, we chose B more than we did D, and then a little bit for A, 13%, and then not much, 9% for C. So this was difficult. This was actually tied for the fifth most difficult item on the test. And this really goes back to this word. What is range? What does that mean? And how are students finding domain versus range versus the x-intercepts, right? You can find all of those three on any function you have, and that could possibly be a strategy for helping these students. Anytime you get a quadratic function, have them find all three to note that they are different things and that we need to look at different things when we are looking at a range or domain. And when we're looking at range, we should always either see a minimum or a maximum, right? That's a whole other standard about the attributes of a graph. So the fact that we only had 34% of our students identify that is a little bit concerning. This is a problem we'll need to come back to as educators. Next, we are looking at calculating correlational coefficients. This is A.4a. And we definitely need our calculator on this. It actually calls for the calculator within the standard itself. So a counselor is asking college students who had jobs how many hours they worked each week. And if we were to graph this, it would be a scatter plot, right? We have these x values and y values are kind of all over the place. They're not necessarily following a pattern like an additive pattern or multiplicative pattern. The question is there a correlation between these two? Now, we're going to use our calculator to find it, but all it's going to give us is it's going to give us an R value. Okay, so we need to know how to interpret, right, the R value. Okay, so I always kind of envision my R value kind of like this, almost like a skateboarding ramp, right? It's going to range from -1 to 1, right? It's going to be anywhere between there. The closer to 0 gets, the less correlation there is. That means we're asking, do you have higher grades because you work more? Do you have lower grades before you work more because you work more? Or is it completely random, right? So if we have anything at 0.7 to 0 to 1, it's what we call a strong correlation or a strong positive correlation. That means definitely the more hours you work, the higher grades you get. Anything between the 0 and the 0.7 is going to be the weak positive. So do you get a higher grade average when you work more? Mm, kind of. That's what a weak correlation kind of gets you, right? It's kind of a kind of. And then you've got that same threshold over here. When we're looking at weak and strong negatives, it's going to be that 0.7, or in this case, that negative 0.7. So a weak negative from 0 to negative 0.7. Now, this is a strong negative, which means it can be highly correlated, but it's in the negative, which means the more hours you work, the lower grade point average you have. So a strong positive means they both go up together. A strong negative means when one goes up, the other goes down. So we now know how to interpret it if we can remember this. Now we've got to open up our calculator. So for this, let's use our TI-84 graphing calculator. Now, before we do anything, we have to turn the diagnostic on. So I'm going to hit second, that blue, and then 0, which is going to get me the catalog. I need to scroll all the way down. This is a different type of calculation, so we actually have to turn on the diagnostic. So it's alphabetical. We're going to go down to our D's, and we're just going to hit diagnostic on. Okay, so we're good. It's done. All right, so now we're going to go to our statistics, and we are going to edit them. When we edit our statistics, we are just going to list our hours worked in our L1. So the only issue here is we don't want to mistype anything, so we do it kind of slowly. And so this is going to end up being one set of values in what we call our L1 or L2. Obviously, we can have more than just two lists, but in this case, we just need two. So we just want to verify that our 72 is across from our 30, our 77 is across from 27, 83 is across from 25, 87 is across from 16, 90, 94. All right, so we're almost there. Now I've got this data in here. I've got my diagnostic on. I'm going to hit my stat again. I'm going to go over to calc. So I want to calculate it now. Now that I've got my data in there, what do I want to calculate? Now, it's asking for the correlation coefficient and what type of linear association. There's nothing on the calculator that says either of those. We need to go to this linear regression, or the linreg, which is number 4. Now it's asking for the lists. We've already done the lists. And so what we're going to get here is, let's write that R value. So we have all of that data. What we really need is that R value. R equals, and I'll just write the first 0.9. Then I've got 0, 0, 0. But let's just keep the 0.9. We're just going to round. So that 0.9, look at that, is going to fall right there. Strong negative. That means the more hours you work, the lower your grade point average. And that does make sense. Look at our lowest hours worked. That correlates with our highest grade point average. Look at our highest hours worked. That correlates with our lowest grade average. Now, it doesn't necessarily follow that it's a straight line. There's going to be some bumps in there, but it is a strong negative. And so that is going to be our answer of A, strong negative correlation. Now, as you could guess, that is a lot of statistics, and that's probably going to be difficult for students, and it was for a lot of our students. We only had 34% of our students get that correct. And then when we're looking at B and C, 23%, 23%. You just had your 4 options here, right? And then 20%. So we are just a hair above guessing. Because when you look at the answer distribution here, it means we're doing a lot of guessing, and some of the students guessed correct. And they're probably at least half of that 34% knew what they were doing, calculated it, got the correct one. But that's difficult. This is tied for our 5th most difficult item on the test. And it really does involve quite a few steps: turning the diagnostic on, getting into the stat, make sure you're entering your list, going to calculating, choosing the correct linear regression. And then all of that is useless if you get the negative 0.9 and you don't know how it correlates. So this is our first teaching point here. Our students need to be able to interpret it. So they need to know what the ranges are going to be, what it means, and some real life examples, such as the more hours you work, the lower your grade point average, probably because you have less time for studying. Then we can get into the technical details of how to enter it. But if we spend all the time on the calculator and we don't know how to interpret it, then we're still going to get the wrong answer. So next we are graphing exponential functions. This is A.9D. And we need to look at a graph and say which statement is not true. All right, well then let's graph. We could do it on either calculator. I always find this to be just a little bit easier to use on this. So let's plug this in. Y equals 16. Then we have 0.5, and then we are going to raise it to the x power. Okay, so what we need to do is we need to hit this AB. The a squared automatically just gets you a squared, but the AB means you get to enter what you want that exponent to be. In this case, I want my exponent to be x. I want it to be a variable. All right, so let's take a look at our graph. All right, so we notice that looks like it's got that asymptote right at about x equals 0. It does cross the y-axis, looks at right at 16. Okay, so those are probably going to be some features we'll be looking at. So let's take a look now. So what's our first statement? The intercept is 0, 16. The y-intercept is 0, 16. Well, I've got it right there. It does cross the y-axis at 0, 16. That is correct, which means we don't want it. We're looking for the statement that is not true. B, the graph is decreasing for all values of x. That means as the x gets larger, it decreases. And on this asymptote here, you notice it's just going to get closer and closer to 0. But it is going to be decreasing, which means that is a correct statement. The x-intercept is negative, or 0.50. Well, first off, 0.50 is right around here. It's going to be, if I zoom in like that, 0.50, we're right there on that x-axis, and you notice the graph isn't anywhere close. Secondly, there is no x-intercept. That 0.5 happens to be my rate. In this case, it's decay rate, right? But it's not the x-intercept. So this is going to be our correct answer because that is not true. We can say the graph has a horizontal asymptote at y equals 0. We've already noted that. Yes, it is increasingly getting close to 0, y equals 0 without ever actually reaching it. That is the definition of an asymptote. So our answer here is C. Now, we did a little bit better on this one. 53% of our students were able to get this if they just graphed it. Visually, there was a lot of clues to help them solve this. Our incorrect answers are kind of scattered here. 18% for B, 12% for A, and then I've got a 17%. So really it was B and D that kind of messed us up a little bit. This is a statement that might not be as intuitive. For all values of x, this implies as x increases, right, the y value decreases. But this is just a different way of saying that. And so students might not necessarily know what that means exactly. And then if you're not sure about what an asymptote is, they can see that that graph looks like it touches 0 when in fact it never actually does. So this is right in the middle. This is our 24th hardest item, or tied for our 24th hardest item. When you're looking at a 50-item test, that's right there in the middle of the test in regards to difficulty. So next, we are looking at graphing inequalities. This is 8.3D, and this is a graphing problem. So we need to, our answer is simply to graph it, but we're probably going to have to work something out here. So let's see, what is the solution set that best represents y is greater than or equal to 1/2 x minus 2? Well, before we get into this probability, if we were to look at it like slope-intercept form, y equals mx plus b, we're going to get some data here, okay? So we're going to get a slope of 1/2. That means it's going to be a positive slope, but it's going to be a positive shallow slope because it's less than 1, greater than 0, minus 2. All right, so I am going to know that our y-intercept is at -2. So I can plot one point right there, and then I can use this slope here to calculate our next point. Slope of 1/2 means it's rise over run. So I'm going to go up 1 and over 2, and it's positive in both ways because it is a positive slope. So up 1 over 2, I can plot 1 right there. And I can also do this up 1 over 2. I can plot 1 right there. Okay, so first, let's get those points in there. So let's get that 2. Let's get that. I've got my line. You see my line follows my slope and my y-intercept of -2. Now, I need to figure out what kind of line I have. So I've got a greater than or equal to. Okay, so my two options are a solid line or a dashed line. A solid line is when we are using equal to, so we can include the numbers on that line. So greater than or equal to or less than or equal to are going to be solid, and then greater than or less than are simply going to be dashed. So it is a greater than or equal to, which means we are good with that solid line. Now we need the solution set. Where's the solution set going to be? I need to select the solution set button and then either tap above or below. Well, it is greater than or equal to, so it's going to be greater than or equal to that line, which means we're going to be shading above. Now, let's verify because we want to get both points here. How do we know? Let's pick any number that is inside that solution set and it should work. Okay? And so let's see. I've got y is greater than or equal to 1/2 x minus 2. Let's pick 0, 0. Let's make it easy. So 0 is greater than or equal to 1/2 times 0, which cancels itself out. -2. Is 0 greater than -2? Yes. And if you really want to verify, you can pick one that's outside of the solution set, right? Like 4, 4, and it would not work. So 4 greater than or equal to 1/2 of 4 minus 2, right? Oh, that's a -4, excuse me. So let's say a -4. So we would say -4 is greater than or equal to 1/2 of 4 is 2. 2 minus 2 is 0. -4 is not greater than or equal to 0. It is less than. So that is incorrect. So that is our answer there, right? We've got a line going through 0, -2, and then 2, -1. We also could move that second point up to that 4, that 0, 4 if we needed to. That 4, 0. And we have a solid line with the solution set above the line. This was a 2-point problem, so to get both points, you needed both of those items correct, the correct line and then the correct shaded solution set. You had 34% of students get both points. You had 15% of students get 1 point, either the shaded solution set or the correct line. And so you put those together, you're looking at about 42% overall mastery, if you wanted to get a percentage on that point, which means we're sitting at 50% of our students got 0 points. We're unable to access this problem in any way. That's pretty low. In fact, this is our 15th hardest item on the test. And this is definitely an item in which the tech-enhanced nature of this, the STAAR 2.0, in which they added all of these new answer types, this one plays a role. We've had a few years now of graphing on a coordinate plane by selecting 2 points and it generating a line. I think we're getting that, but it's the type of line and it's the solution set. That's definitely one where it works. It's just not the most intuitive, and we need to give our students lots of practice with just that, itself, that mechanism of cambium. Next, we are solving systems of equations. So we've got 8.5c here, and we've got a word problem. We've got a realistic real world scenario. We've got customers purchasing coffee and donuts. Each coffee costs the same amount, so we can use it as a unit rate. Each donut costs the same amount, so we've got the same rates there. So the first customer paid, and then we've got certain values. We got coffee and donuts, coffee and donuts. All right, so coffee is listed first. It comes first alphabetically. Let's make our coffee X. Donuts is second. Let's make our donuts Y. So coffee X, donuts Y. Let's translate this into a statement. The first customer paid $4.90. I'm going to put 4.9. I'm just going to put this as a decimal, equals, that's how much the cost was. What did they get? They got 1 cup of coffee, so that's 1x. And we're going to add the other thing they purchased, which was 2 donuts. So that's going to be 2y. So 4.9 equals x plus 2y. Now, the second customer paid $8.60 for 2 cups of coffee, 3 donuts. So let's do an 8.6 equals, now I'm going to do 2x plus 3y. All right, so now we're looking for the cup of coffee. The cup of coffee is x, so we need to find x. Well, we need to eliminate one of these variables. And when we're lining it up like this, it's really nice that the coefficients line up. In this case, they don't. But if we double this, then we would end up getting a 2x, and I can subtract the 2x from the 2x, and we'd be good. That would still leave me with y, so I'm going to have to plug that back in. If not, I have to multiply both equations to get the 2y and the 3y together. I'd rather just multiply once. All right, so let's multiply this, right? We are going to get 4.9, right? Double that, that is going to be, and it's going to be 9.8. We'll just put it right down here. Equals, and I'm going to distribute this, right? 2x plus 4y. All right, so let's just subtract both of these equations. All right, so when I got my 8.6 minus my 9.8. That is going to give me negative, but if you look over at the y's, that's also going to give me negative, so it's not going to be a problem. It would be a problem if you end up with a negative value um, for a variable, but what it's going to end up being is 0, because that cancels out, right? Plus negative y, or I'll just say minus y. So really what I ended up with, negative y equals 1.2. Let's just multiply everything by negative 1, so I get y equals $1.20. All right, so my donuts cost $1.20 each, so I'm just going to plug that back into either one of these. Let's just plug it back into that one. Let's say 8.6 equals 2x plus, and then I've got my 3 times 1.2. So that's going to be 8.6 equals 2x plus, that's 3.6. Well, let's just subtract 3.6 from both sides, and you get 5. It's going to be nice and easy. 5 equals 2x, which means x equals 250. $2.50. And I could have plugged it into the other one. I can plug both my 120 and my 250 into either equation just to verify, but they are going to work. So that is our answer A. Now, how did we do across the state of Texas? Well, we did fairly well. We had to set up our own equations, but we hit our threshold of 60%. So good job, students in the state of Texas. That might not seem like a lot, but for a STAR question, that's our threshold of we got this. Now, here's the sad thing. 22% chose B. I don't even have to tell you, but I will. You know where B comes from. They did all the work. They did the calculation. They set up the equations. They subtracted the equations. They isolated the variable. And they chose not the coffee, but they chose the donuts. So if they did what I did, they got their 120 first. They saw the 120 and they were like, yes, I got it. Answer is done. And so obviously those students knew what they were doing. That number could have been a lot higher than 60 if they would have taken a little bit of time and just verified that the Y was actually their donuts, not the coffee. We're looking for X, the coffee. We had 7%, 10% on C and D, which is pretty close to statistical noise. And this was definitely on the easier side of the STAR test, 18th easiest item on the test. Next, we are writing linear equations. This is A.2c, and we have the graph of a function here, and we simply need to find the function that best represents this relationship. You notice all of our answers here are in slope-intercept form. So we are looking for two things. We are looking for the slope, that's the change in y, over the change in x, and then b is our y-intercept. So let's start with that because I find that always pretty easy to find. Where does our line cross our y-axis? And it's going to be that -5. So I can go ahead and plug that in. If b equals -5, I can say y equals mx minus 5, or plus -5. Now I need to find the slope, so I want to show the change in y over the change in x over 2 points. I'm looking for another point that seems to cross at 2 integers, and honestly, our x-intercept looks like it's crossing right there at -3, 0. So what I want to do is I want to first find the change in y over the change in x. Now you can go ahead and graph 2 points, right? It looks like we've got 2 points here. I've got a -3, 0, and I've got a 0, -5. We could do that. Or you can just count hops on the graph, and I'll do that second. So I'm going to go 1, 2, 3, 4, 5. I'm going down 5, so that's going to be -5, and I'm going over 3. 1, 2, 3. That's a +3, so it's going to be a -5/3. So I can plug that in as my y equals -5/3 x minus 5. And we have that answer there at C. And that was not very difficult for our students. We had 72% of our students get that correct. So that is fantastic. We should be very pleased with that. We had 13% choose A, so we had the correct y-intercept, They just kind of inverted this. This is the change in x over the change in y. They kind of flipped the slope, which is a common mistake. We'll see. Let's see, 9% and then 6%, kind of statistical noise. Not that difficult. In fact, sixth easiest item on the test. So this one was a gimme for a lot of our students, and we should feel pretty confident about that. Next, we are looking at real-world systems of equations. This is standard A.3G, and we've got problem situation about hikers, and they're hiking beginning at the same distance from the same time, different locations. So the time, right? My time is my x-axis. They're both starting at 0, but you notice they're starting at different starting locations. Okay, we've graphed their equations here. We're not given the equations, we're simply given the graphs. And we need to find when they are the same distance. Okay, so the distance, right, is on the y-axis. Okay, and so my time is on my x-axis. So we're the same distance. And the question is how many hours have they been hiking? Okay, so they are right about, I'm going to call it right there. And I'm going to say that is an x of like maybe 1.4 and a y of, that looks like to be about 4.5. Okay, now I've got basically, if I call this 1.3 my 1.4, since we are estimating, I got my 4.5 right there. Both of those are there. So let's look to see what the question is asking. Which value best represents the number of hours? Okay, so I'm looking for my time. My time is in hours, and my time is my x value. So I'm looking for the number of hours, which means I'm looking for B. I said 1.4. 1.3 is close enough. And so that is my answer, B. And we did okay on that. We did 61%, so not as good as the previous problem, but still above that 60% threshold there. We had 15% choose D. I would actually expect probably more students to choose D as an incorrect answer, but it really didn't distinguish itself from C, 2.5, or A, 2.8. So we've got 11% right there. We got 12% right there. And so for the most part, we did pretty good. We found the cross, and then we just had to identify, is the question asking for the y value or the x value? In this case, it was asking for the x value. And this was pretty easy. This was tied for 15th easiest item on the test. So it's just a visual looking, no calculation, and we just had to identify which value is it really asking us for. For number 16, we are factoring trinomials. This is A.10e, and we've got a trinomial here, this large function, and we are simply needing to factor it. Now, if we wanted to, we could just take each for answer choices. We could use the distributive property or FOIL, and we can just plug away and find one that equals. And that is a perfectly valid strategy, but sometimes we will be asked to factor this in and we won't be given any answer choices. So I want to focus on strategies that we can use without any answer choices. And so there are a few different ways to do that. So the one I'm going to show isn't necessarily the only one. Obviously, we can use the quadratic equation. I always like factoring out, so I'm going to focus on the factoring, but the quadratic equation always works. Either way, what we need to do is we need to remember our standard form because we're going to need the a, so that's going to be ax squared plus bx plus c. We're going to need to know the a and the b and the c terms. And really what we're looking for is what are two numbers that multiply to whatever a times c is, but add to b. And if we can do that, then we're good. So I kind of use this visual here to keep track of what I'm looking for. But really, I'm looking for two numbers that multiply to the product of a times c. And we're already getting pretty large here. I'm going to open up my calculator because my a is 6, my b is negative 23, and my c is 21. So I need two numbers that add to negative 23, but multiply to whatever a times c is. That's 6 times 21. So that's going to be 126. So two numbers that multiply to 126. Let's start listing out factors of 126, right? I'm going to 126. Obviously, I can do 1 and 126. Those two would not add to negative 23. And since it's going to be negative, I'm going to probably make, I can make both of them negative if they are needing to get to a negative, because two negatives would add up to a positive, right? So let's just kind of keep these as negative. If I take my 126 and divide that by 2, I'm going to get 63. That's not going to work. Still would add up to negative 65. Now I'm just guessing here. Does it divide by 3? Right, yes, 43. Getting closer, but not quite there. That would be negative 46. Let's see if negative 26 can be divided by 4. Nope. Not by 5, because it doesn't end with a 5 or 0, but maybe 6, because it can be divided by 2 and 3, which means it should be divided by 6. It's going to be 21, negative 6, 21. I'm getting pretty close, because look at that. That is negative 27. Okay, so let's try 7. All right, so negative 7, negative 18. Now I'm at negative 25. Really close. Let's try 8. Let's try 9. And I think we've got it. Look at that. Negative 9, negative 14. If you add those two together, right, negative 9 plus negative 14 equals negative 123. And negative 9 times negative 14 equals positive 126. All right, so what I do here is I write ax over my two factors, okay? So my a is 6. So I'm going to write 6x over, what's my one factor? Negative 9. I'm going to write 6x over my other factor, negative 14. And then that ends up turning into my two different numbers. Now, what I could do before I try to find those is, can I simplify those, right? Well, I can simplify this, and I could make it 2x over negative 3, which translates into 2x minus 3. And then I can divide both those by 2. That can be 3x over negative 7, which becomes 3x minus 7. And we see that right there. We see that up there at A. Obviously, if we need to, we can multiply that back out using the distributive property. And a lot of students, if they were just using the plug and play and going straight through the distributive property, that was the first one available. So that was probably pretty good for them. In fact, we did pretty well at this because there were multiple methods to solving this. We actually got 68% of our students to get this correct. So that is pretty good. We should feel pretty solid about that. 11% for B, 14% for C. That was the most chosen incorrect answer. Then 7% for D. But overall, we did fairly well. Seventh easiest item, or tied for the seventh easiest item on the test. Number 17, we are looking at domain and range of exponential functions. This is 8.9a, and this is a multiple select, so there are two correct answers we need to find. And what we should notice here is that we've got this graph, and we've got three statements about the domain, and then we've got three statements about the range. So I'm going to infer that one correct statement is from the domain, one correct statement is from the range. So let's just make our own decisions about what the domain and the range are. So the domain's the set of all input values. So we can think of them as input values. We can think of them as independent variables. Most of us just think of them as your x-coordinates, and that's fine. So what are the x-coordinates that we are going to include on our graph? So it's parts of an exponential function is what it looks like, but not all of it. So we've got closed circles. So we need to keep that in mind. That means we're going to include these numbers that it lands on, and we're talking x first. So it's x is going to be greater than or equal to 2, because it's got a closed circle at 2, and it moves to the right of 2. And it's going to be less than or equal to, I've got that 5. All right, so between 2 and 5 are my x values, and then we've got my range. So those are the output values. Sometimes they're viewed as like the f of x, right? Those are the dependent variables. Or sometimes we'll just call them y coordinates, and that works as well. So what are our y values? So y is greater than or equal to, still a closed circle. And at this point, we're looking at the y value. So it's greater than or equal to 1, and it's less than or equal to, and I've got that 8 up there. So we just need to keep those in mind. All right, and so we're not going to say the domain is the set of all real numbers, nor is the range the set of all real numbers. It could be if they didn't chop it off on two ends with this exponential graph. So let's look at our domain first. And you notice, look what I have on both, a 1 and an 8, a 1 and an 8, and then I've got a 2 and a 5, 2 and a 5, right there. So really it's just trying to figure out, do I know which one is which? Well, we've already said our domain is all real numbers greater than or equal to 2, less than or equal to 5. And if that's the case, then that can't be my range. My range is going to be right here, greater than or equal to 1, less than or equal to 8. So my answer choices here are my option 2 and then my option 4, or B and D if you want to give them letter values, option 2 and option 4. So let's now see how we did across the state of Texas. And this is a 2-point problem, so we're going to get different type of data. We actually had 49% of our students get both items correct, so that's decent. Another 28 get one item correct, partial credit. We don't know which one was correct more often than the other, if anything. So you take 14 points, which is half of the 28. You add that up there, you're going to get 63%. So for the most part, we should feel pretty good about this item. 23% got 0 points. So that's not necessarily good, but overall 63% mastery. This was tied for our 12th easiest item on the test. They did set it up pretty easily for us with bounds on either side. Even though it was multiple select, each set was the same. 1, 8, 2, 5 are all. 1, 8, 2, 5 are all. So hopefully the students were analyzing the problem like that, noticing the pattern there, and then helping that to kind of clarify their thinking. For number 18, we are solving quadratic equations. This is A.8a, and we've got a function here, and we've got those terms, and we need to find the solutions of g of x equals 0. So when we're solving it, we're looking for solutions. We've got a few different choices, right? We can factor it. We can always use the quadratic equation. For this one, let's go ahead and use the quadratic equation. And so, in case we forget it, right? Our standard form, we need to keep in mind, is going to be f of x. Well, this one says g of x. But you've got the ax squared plus bx plus c. We'll need the a and the b and the c. So I've got my 3x squared minus 2x minus 5, which means my a is 3, my b is a negative 2, my c is a negative 5. All right, so my quadratic formula here is helping me with my solutions, and that is my negative b plus or minus square root b squared minus 4ac over 2a. So at this point, we are now just plugging in values. So x equals negative, and then my b is negative 2. So that's going to end up being a positive 2. B squared, so negative 2 squared, minus 4 times a times c. I've got a negative 5 back there, so the minus 4 and the minus 5 are going to end up being a positive. And then I've got a 2 times a, which is 3. So let's start simplifying. We're going to see negative, negative 2. That's going to be 2 plus or minus. Square root of negative 2 squared is 4. And this is going to be negative 4 times 3 is negative 12. Negative 12 times negative 5 is going to be 60. Okay, so plus 60. So that's going to be a nice 64. So that's going to help us here. and that's going to be a 6. So we can say 2 plus or minus square root of 64 over 6. 64 is a nice perfect square, so we can now say 2 plus or minus, let's just take that square root out of there. Let's just say 8 over 6. So we need to think of that twice, right? X equals, so what I have here is a 2 plus 8 over 6. I also have a 2 minus 8 over 6. That's where this plus or minus comes into account there. Is that plus or minus whatever emerges out of that square root. So that could be 10 over 6, right? That could be a negative 6 over 6, which is going to end up being a negative 1. Now this 10 over 6, let's go ahead and simplify that to 5/3 and negative 1. And so when we're looking at 5/3 and negative 1, those are my two choices. X equals, got them right there. So that is my answer, B. Now we could have factored it. We could have gotten the same answers. So there's always a few different ways. We could have even completed the square if we wanted to. So for this, we had 54% of our students complete that correctly, get the correct answer. And we had 21% choose C, right? And you notice here that it was just the inverse, right? Inverse of sine and then the inverse of the 5/3. And then we had the 1 rather than the negative 1. So we had sign errors when we were most likely factoring rather than using the quadratic formula, and they just had a sign error. We had 14% for A, and then 11% for D. So for the most part, it was on the easier side, 25th easiest, right there in the middle of a 50-point test or a 50-item test. So not the easiest, but definitely not the hardest as well. So number 19, we are writing exponential functions. This is A.9c, and we have a table represents some points, and we need to find which function best represents that. So it doesn't say exactly what we need to do. Our clues are they're going to give it to us an exponential function, and unfortunately, we don't have the standard form of exponential functions or any exponential functions on our reference materials. We have linear equations, we have quadratic equations, we don't have exponential equations. So we need to remember what our standard form is. Okay, so I'll put it in g of x since that's what we're using for this one, right? A times b to the x. So a is our initial value. So what is our initial value? Well, that happens when x equals 0. So we don't have that here. What we're going to need to do is we're going to need to extend that up here. And we're going to need to get a value for that. Okay, so it's not going to be 48. The initial value is what happens when, if x is 0, this turns into 1, right? Because b to the 0, anything to the 0 equals 1. So then that just leaves you with a. So we can, honestly, eliminate 48. So it looks like it's going to be 32. Now B is our rate. It's going to be our growth rate or it's going to be our decay rate. Now look at how we're going from x of 1 to 2 to 3 to 4. It is a growth rate because our terms are getting larger. Now, sometimes they'll give you the growth rate. They'll say it's a 5% growth rate, 10% growth rate. They don't give you anything except values. How do we calculate our rate here? Well, what we could do is we can find the rate by dividing a term by the previous term, right? So what we want is we want to divide g of 4 by g of 3, or, right, g of 3 by g of 2, or so on and so forth. So let's get our calculator out. Okay, so g of 4, let's start with that first, is 162. So what is 162 over g of 3? 108. 162 divided by 108, 1.5. Since we're doing um, decimals. We're not doing decimals, we're doing fractions. Let's simplify that 1.5 is the same as 3 halves. Now, if that's the case, if my b equals 3 halves, now we need to see if that holds true for all the others. Okay, so that means technically if we do 108 over 72, it would be the same thing. 72 over 48 would be the same thing. 48 over whatever our, missing number is, our initial value. In this case, it looks like 32 is our only option. Let's just verify. So 108 divided by 72. Yep. 72 divided by 48. Yep. And then 48 divided by 32. Yep, that is correct. So then our initial value is going to be 32, which obviously that's the only choice, but our growth rate here is going to be 3 over 2, not 2 over 3. Now, how could we figure that out, right? Well, if we know that g of 0, right, equals that 48 over 32, or 48 over this blank, we know that that also equals our growth rate, right? We could do some cross multiplication here if we needed to. We can take 96, divide that by 3, right? And that would get us our initial term. Or you can take your 48 and you can multiply it by the inverse, right? Instead of dividing it by, 3 halves, you can multiply by 2/3, which ends up being exactly what we just did, 96 divided by 3. Either way, there's multiple ways to get 32 if you didn't have any answers to choose from. But our answer here is going to be C, and we did pretty well on that across the state of Texas. We had 59% of our students get that correct, so just a hair short of that 60% threshold that we are looking for. And then the rest of the answers were pretty evenly distributed. 17%, 12%, 12%, which means there's not really a distractor that was setting our students down the wrong path. You either knew it or you were guessing, most likely, because the answers were very similar with the 48 and the 32, and then your growth factor of 3 over 2 or your decay rate of 2 over 3. And so this was 59%, and this was our 19th easiest, or tied for our 19th easiest item on the test. For number 20, we are looking at association and causation. This is standard 8.4b. We're using our reasoning skills. We're not necessarily calculating anything here. We need to find a situation that best represents association but not causation, right? So this is not going to be helpful unless we know the difference between the two. So association is a relationship between two variables that they tend to occur together more often than would be expected by chance, but it's not what's that next term, that causational. So there is a relationship between two variables, and they tend to happen together, but one doesn't cause the other. Causation, think of that word cause. Because of this other thing always happens. So this is one thing causes another. So example, there is an association between ice cream sales and drowning deaths. Now, those two tend to happen together because there is a third factor, summer weather, which kind of drives both. But you can't say that ice cream sales are causing drowning deaths, but they both are associated. They both increase at a certain time. That's the summertime. You can say that smoking causes lung cancer because it's the chemicals from cigarettes that damage the lungs and eventually cause cancer. So that's kind of the difference there. So let's take a look here. A, when the number of spectators at a football game increases, the number of wins for the home team increases. So you're saying that this causes this. Well, if that were the case, then some of the most popular teams would always win, but that doesn't always happen. Spectators don't cause the home team to win. Now, spectators are more often to show up when the home team is winning because people like watching winning football. So I'm thinking this is it because those are related, but spectators increasing doesn't make the team win more, even though they do like playing in front of friendly fans. B, when more gallons of water are put into an aquarium, the weight of the aquarium increases. Yes, this definitely causes that because water has weight. Water is actually very heavy, so increasing the water will increase the weight. So it's not this one, because that is causation. C, the amount of time an athlete runs increases, the distance she runs increases. Assuming we're not running on a treadmill, but even on a treadmill, we are tracking the distance. Yes, time is the cause of distance because each second an athlete is running, they're running a certain distance. So that's not it. And then the charge of cell phone battery increases, the number of minutes the phone could be used increases. Yeah, we all know about cell phone battery usage, and more charge causes more usage or more minutes that we can use. So it's that first one, A, that is associated, not necessarily causational. So how did we do here? Well, we had 58% choose A, so pretty good. We had a smattering across the rest. We had 13% for B, 17% for C, and then 11%. And I would wager that those students really didn't understand these terms, and so we're kind of just left with guessing because this one is very difficult to figure out if you don't know what those two terms mean and what we're looking for. So this was pretty easy. In fact, this was tied for our 22nd easiest item on the test. For number 21, we are looking at parent functions. This is A.7c, and we've got two different quadratic functions that are graphed. We've got f and we've got g. And so we have f of x, and so this f of x is your standard quadratic function, right? F of x equals x squared. It's reflected across the y-axis. It's got its minimum at the origin. It's just your vanilla quadratic function, but it gets shifted over, it gets shifted down, and it looks like it narrows a little bit. So what is an equation that we can use for that? Well, we do a lot of work with this. We need to remember that there are several factors that influence this, and this one actually hit all three of them, right? So we think of it like this, g of x, or whatever your transformed graph is, in this case it does happen to be g of x, equals, so there's some type of multiplier, right, outside of the f, and if you have something inside that f of x, right, that's handling what's going on left and right, and then if we add anything onto the end, that is happening what's going on up and down. Okay, so let's first deal with the C and the D. That's actually going to be a little bit easier. So let's look at the x value of our minimum there, right? Our axis of symmetry. It's at 0, 0. All right, so now our new minimum right there, the x value is 3, so it gets translated 3 units to the left. Okay, so 3 to the left. Or we can say minus 3. Now, that's what happens with our C. So C equals minus 3. So if I'm going to plug that back into here, I'm going to say x minus 3. So that's going to end up becoming a positive. So that's kind of the trick with that C that goes left and right. You need to subtract it from x, and so if it actually is a negative, it turns into a positive in the final form. And we see that we've got two of those options right there in A and B. Now this plus D is pretty straightforward. If it moves up, then it's going to be a plus D, positive number. If the graph moves down, it is going to be a negative number. In this case, we went from 0 to, to negative 2. Okay, so we went 2 down, or minus 2, so we can say our D equals negative 2. So we can rewrite this again now. Bring this g of x down. AF, I'm going to go ahead and just make this x plus 3. And then that d is going to be minus 2. Now, I still need to think about this a. Has it narrowed or stretched? And in this case, it has narrowed. That's going to deal with my a right here. Now, what happens is, if the a is, right, greater than 0, right, but less than 1, so it's a decimal, it ends up widening. And it didn't necessarily widen. It just ended up uh, narrowing a little bit. So that's going to be what happens when a is greater than 1. It's going to narrow. And the higher that a is, the thinner and thinner and thinner. If you were to make a 100, it would almost look like a straight line, unless you zoomed in really close. And so we can say that it narrows. Now, calculating that is a little bit of a challenge, but we don't necessarily need to because we just noticed that there is only one of these two terms that actually has a 2 right there, right? So it is going to be g of x equals 2 to the f, and then multiply that by f of x plus 3, and then minus 2 after that. So our answer here is B. Now let's see how we did across the state of Texas. So we had 44% of our students get that. This was a pretty complex parent-child function problem because we're dealing with a vertical translation, a horizontal translation, and a stretching, or in this case, it was a narrowing. So that was difficult to hit all three of those. We had 27% choose A, which it's the wrong answer, but you don't feel as bad because they got both the horizontal movement and the vertical movement. They might not have just been looking at the whether or not it was widened or narrowed. And then you had 19%, right? And the problem here is we see this x plus 3, they made that an x minus 3 because it goes 3 to the left. Now that doesn't help you with that plus 2. That's still wrong. And then we've got 10% down here at D. So this was difficult. This was the 17th hardest item on the test. And I really think, the two that are the most difficult are the horizontal changes because it's an x minus c. Then I do think we need to spend a little bit of time really thinking about that a and what happens when we multiply outside of the f of x and what makes it widen, what makes it narrow. Students need a good frame of reference for that. For number 22, we are graphing functions and identifying features. In this case, we are graphing functions. This is A.3c, and it's using the graphing feature of our test, and we need to just create a line. Now, they don't give it to us in slope-intercept form, they give it to us in standard form, but it's not that difficult to put it into slope-intercept form. I want to take this 2x plus 3y equals 6, and I want to translate it somehow into y equals mx plus b, simply because if I do that, I can get the slope, I can get a starting point with my y-intercept, and that's all I need. Those are my 2 points because it's a straight line. So let's take 2x from both sides. All right, that's going to remove that. I'm going to get 3y equals, it could be 6 minus 2x. I'm going to go ahead and put my minus 2x plus 6. I want that first because that's the mx plus b. Then I need to divide both sides by 3. If I do that, I've got my y equals. Now I'm going to go ahead and distribute this, right? You could do minus 2/3 x plus 6 over 3, which ends up making 2. All right, so there we go. I've got my uh, y equals mx plus b. My slope is minus 2/3, which means it's going to be moving down from left to right. And then I've got a y-intercept of 2. So let's start with that. My y-intercept is going to be 2. And then I need to think of a slope that's negative 2/3. So slope is rise over run. So let's go down 2. Then we're going to go over 3. 1, 2, 3. So I'm going to go through those 2 points, 0, 2, and 3, 0, which happen to be just the y-intercept and the x-intercept. And if we do that, we are going to get that line. And that is the correct line for the equation 2x plus 3y equals 6. So how did we do? Well, this is a 1-point problem. And so we've got 1 point at 35% correct. So that is pretty low. And obviously 65% didn't get anything. It could have been the fact that this is graphing. Graphing is a fairly new tech-enhanced item, though this is the second year we've seen it. So hopefully students have had to practice a little bit. Honestly think it's this. Putting it in standard form, converting it to a slope-intercept form, especially because your m is not an integer, that might have messed them up. Or they could have gotten all of this correctly and they could have interpreted it wrong. They could have had their slope or their y-intercept right there, and they could have done run over rise. They could have done like down 3. Let me change colors here. Could have done down 1, 2, 3, and then over 2, and then try to draw that line, right? You could do all that work, and if you don't know that this is rise over run, you could still get the incorrect answer. So this one is a challenge. This actually is tied for the 7th hardest item on the test. Difficult to know whether it's the use of the graphing or whether it's not knowing how to interpret the negative 2/3 given the y-intercept, or whether it's the conversion from the standard form to the slope-intercept form. Could have been any of those points that made this challenging for students. Number 23, we are looking at domain and range of linear functions. This is a point to a, and we have a verbal description. So we've got a problem here. We've got a swimming pool that can be rented for 110 per hour. The pool can be rented for either 1 hour or 2 hours, and the cost is a function of the pool. Okay, so a cost is a function of the number of hours that the pool rented. So when we say the cost of in dollars is a function, that's going to be our f of x, or what we think our y, right? It's going to be the dollars, because we're trying to label our variables here, and a function of the number of hours. And so that's going to be our x, which makes sense. Our x is always our independent variable, right? When you want to rent something, you go up and say, well, I want to rent it for this many hours, and then they tell you, okay, this is how much it costs, because they already know the cost per hour, in this case, the 110. You don't walk up with a stack of bills and say, how long can I rent it for? You specify how long you want to rent it for. They give you the cost. So that's the dependent variable, is the cost. Okay? So, I mean, let's think about this. If the x is the hours, and if the y is the pool, we're also thinking of our x and y in terms of what we're going to need. Our domain is always the set of independent variable values, or x values, and our range is always our set of dependent variable values, or our y values. And sometimes it's continuous when we're looking at a function of just a traditional linear function. But in this case, it's going to be discrete because they tell us in the actual problem, it can be rented for 1 or 2. That's it. You want it for 1 hour or you want it for 2 hours. All right, if I want it for 1 hour, what's it going to cost me? 110 bucks, because it's 110 bucks per hour. Double that if you want it for 2 hours. That's it. You can't rent it for 3 hours. You can't rent it for 0.5 hours. That's why it's discrete. There are just a certain number of data points. Continuous is just a straight line. It's every single number imaginable. So we've got our domain right here. Mine is vertical, but we can look at it side to side. We can say our domain here is that those brackets there, curly braces in 1 and 2, and then our range, it's going to be 110. It's going to be within those curly braces, 110 and 220. So our answer there is B. Now this one is really looking at, there's no calculation needed. It's really looking at what does it mean to be the domain? What does it mean to be the range? They're not 100% identified in the problem. So you have to read the problem and interpret it and figure out what are the dependent and the independent variables. And how did we do on this? Well, we did okay, kind of middle of the road, 46%. And you probably, if you're looking through the answers, you're already identifying what the most chosen incorrect answer is, and that would be A, 38%. And that's when you switch the domain values with the range values. So if you're putting both of those two together, right, you're looking at like 84%. That's a lot of students that at least identified 110 to 20, 1 and 2. Problem is half of them, less than half of them were able, or were able to do it correctly, or less than half of them switched, and slightly more than half of this 46% were able to at least put them in the right spots. For C, we had 11%, and for D, we had 5%, which these just don't make sense. They don't really fall within the problem, so this is kind of hitting in that area of what we're going to get when students are just randomly guessing for those. There's not really much of a rationale for C or D. So this is the 19th hardest item on the test, and probably the challenge here is definitely going back to what we learned in 6th grade. This goes all the way back to 6th grade. What is an independent variable? What is a dependent variable? How do you identify those within a problem situation? Because your independent variable is your x in your domain. Your dependent variable is your y in your range. If you can identify dependent, independent, you can identify domain and range. Next, for number 24, we are looking at linear equations and the distributive property. This is 8.5a. And we just need to find a value of m that makes the equation true. Now, we've got a few options here. We can solve for m, which we can work through, or this is multiple choice. They give us 4 answers. Students might just elect to plug each of these in and just plug and play and find the correct answer. When you are given 4 answer choices, that is a valid strategy. Of course, this could have been a free response, text entry, and equation editors, which means you would have had to learn how to do the work yourself. So let's do that. Let's distribute this out. So 2/3 m minus 9. I just want to deal with this first expression right here. So I need to distribute this out. So because it's being multiplied by the outside of those parentheses, so I need to multiply that 2/3 by both terms inside that expression. So I'm going to multiply 2/3 m. It's pretty easy because it's just 2/3 m. Those are different types of terms, so I'm just going to slap them together. Now what I need is I need minus, and I need 2/3 times 9. It's going to be a negative, so I'll just keep it on the outside there. That's going to be not really difficult, but slightly, slightly challenging there. So I'm going to simplify this to 2/3 m minus, so I can think of this as 9/1, right? So that's going to be 18/3. So that's going to be 18/3. So when I simplify that, I'm just going to think of that as 6. Okay, so let's do the same thing on the right side. So 1/3, and then it's outside m minus 27. We're going to distribute this out. It's going to be 1/3 m minus 1/3 times 27. I'm going to think of that as 27/1. So that's going to be 1/3 m minus, and then that's 27/3. So I'm going to think of that as 9. So I'm just going to put a 6 right here. I'm going to put a 9 right here. Now, I want to get the m's together. Now I want to, isolate the m. So I need to subtract 1/3 m from both sides. That's going to get rid of that. So that's going to give me 1/3 m minus 6 equals, I've got a negative 9. Let's add 6 to get that over there. 1/3 m equals negative 9 plus 6 is going to give me negative 3. I'm closer to 0. Now, most of us are used to when we have that coefficient outside of a variable, it's an integer, and you end up dividing by that because that's the reciprocal. Some of us might not be so used to what if that coefficient is a fraction. We still have to multiply it by the reciprocal. But in this case, right, it's going to be, instead of dividing by 3, that wouldn't get rid of it. That would just make it smaller. We need to multiply both sides by 3, because 3 times 1/3 is going to make 1. So I need to multiply both sides by 3. That's going to give me m equals negative 9. If we want, we could plug both of those in. We would get the correct answer. So some students might have chosen to do this way. They might have just did a plug and play. And if so, they would have lucked out because it was the very first answer choice. So our answer here is A. And we had a decent amount of students get this correct, 61%, so above that threshold that we're looking for. So that's pretty good. We had 21% choose C. So that was definitely a distractor. So let's take a look at that for a moment. So B has -3, got 21%. And so really what this is instead of subtracting that 1/3 m, they might have added that 1/3 m to both sides, which 2/3 and 1/3 would have just made m, and then that would have just made uh, everything a little bit easier. Would have ended up with that. If this 1/3 became a 1m, then we would have ended up with that -3 right there. And that's calculator-wise or calculation-wise, it's a lot easier. So some students might have done that simply because it was easier, even though it was the wrong move. You had to subtract 1/3 m from both sides, which still left you with just the 1/3 m on its own. So this is the 15th easiest item on the test. We're tied for the 15th easiest item on the test. And the fact that we're over 60% makes us feel good. Next, we're looking at number 25. This is the attributes of quadratic function graphs, A.7a, and this is a drag and drop, so this is a 2-point item. And we are trying to identify the function has a blank value of blank. Okay, well, if you take a look at our answer choices, it's either minimum or maximum. Now, you notice this minimum can only go, you see how that's blue right there? Minimum can only go in that first box. Same with maximum, only go in the first box. And then you see this -4 can't go in the first box. Any of these number values can only go in the second box. So really, when we're looking at this, not all answers can go everywhere. I'm looking at minimum or maximum, and then value of what? Okay, well, this is a traditional quadratic function. That means it's opening up, which means we have a low point at -4. And so the values always rise from -4 and they never stop rising. That's what these arrows mean. They go on infinitely, but they will never go below -4, which means it is a minimum of -4. It's never going to go below. We don't have a maximum unless it's opening downwards and we flip that upside down. But a minimum -4, that's it. That's the entire problem. And so this was a fairly easy problem. Even though it was a 2-point problem, we had 64% of our students get both points, which is fantastic. We had another 26% get 1 point. Not sure which one they worked on and missed and which one they worked on and got correct. We don't get that level of data, but if you take half of the 1 point, that's 13. Now we're looking at 77% mastery. That's great. We really, really did a fantastic job with this. Now, of course, we still have 10% of students that didn't get this. You had a 50-50 chance of getting this one right here, the minimum maximum. So you had to, choose incorrectly on that one. But this was tied for our 10th easiest item on the test. So this was one in which students probably felt pretty confident working through. Next, we're looking at number 26, writing systems of equations. This is A.2i. And so we've got some verbal descriptions here, and we need to turn them into a set of equations here. All right, so we've got hot dogs, we've got bags of popcorn, and they go ahead and label things for us, right? Price in dollars of hot dog is X. Okay, so I'm going to say, just going to take this X and I'm going to replace hot dogs with X. So I'm going to I'm going to put it right there. And then bag of popcorn is Y. So let's replace the bag of popcorn. I'm just going to put it right there. And then I'm going to put it right there. Okay, so if we read the problem, it literally tells us what the answer is now that we've got our X's and Y's. One family paid $8 for, so that $8 for means 8 equals 2 hot dogs, 2X. We're going to add, because when you buy a whole bunch of things, you end up adding them, 3 bags of popcorn, 3Ys. So we need an 8 equals 2X plus 3Y. And we don't even need to do the second one, because that's the only one that has it correct. Now we can, just to verify, another family had 1650, 16.5. They're not going to do the 0.50 since we're taking the dollar sign off. For 5 hot dogs, that's 5x. 4 popcorns, 4y. 16.5 equals 5x plus 4y. D at least has the correct answers and the correct coefficients here. They're just with the wrong variables. A and B start mixing up the variables, but our answer here is B. This was not that difficult. And the students definitely let us know 73% of our students got this correct, so that's great. We should feel good about that. Coming off another one previously, number 25, that was also pretty easy. So there was 2 in the middle that they really did a good job with. And really, we're kind of looking at statistical noise here. This was our 5th easiest item on the test, so we should feel pretty good about this one. It was pretty straightforward, nothing super difficult with that one. Next, for number 27, we are looking at 8.9d. We are graphing exponential functions. Okay, 8.9d. Now, we have an exponential function, has some characteristics. We have a y-intercept of 2. We're just trying to match the graph. So y-intercept is a y-intercept, whether it's a linear equation, a quadratic equation, or an exponential equation. Which means A is no good, because look, it's got a y-intercept of 1. Let's look at B. No good. Y-intercept of 1. Like, we're already getting rid of 2. C, possibility, it's got a y-intercept of 2. D, possibility, it's got a y-intercept of 2. Now, the only other clue we have is, but we're down to 2. So we've eliminated A and B. The function increases. It doesn't really matter what that rate is. We're not trying to get technical. Is it increasing or decreasing? Well, look at this. That's an increase. That's a decrease. So then that's our answer, C. It's the only one that has a y-intercept of 2 and an increase at 50. This was fairly straightforward, and our students definitely mirrored that sentiment. They had 74% completion rate of the correct answer of C, so that was fantastic. Now, the most chosen incorrect answer was 16% on D. It at least had the right y-intercept. They just didn't really, and it probably does have a decrease of 50%. They really were looking more at the rate and guessed. They really didn't clue in on this word increases. We had 6% for A, 4% for B, so we're just guessing here. So this was our 4th easiest item on the test. Students did a really good job with this graphing exponential functions. For number 28, we are looking at equations for parallel lines. This is standard 8.2e, and we have just a single line graph with an additional point on the graph. And what we have here is a statement that asks for the best representation in point slope form. So that's going to be a little bit challenging because we're typically used to slope intercept form of a line that passes through point W and is parallel to line P. All right, so we could draw it really simply. It's going to go through point W. It's going to be parallel to line P. So this is the first thing that we need to know, and it's not necessarily on our reference materials, that parallel slopes are congruent. So that means if we find the slope of line P, then we also know the slope of line W. And so then we can use that to fill in our point slope form. So let's go ahead and bring that point slope form into our problem here. Point slope form is going to be y minus y1 equals m x minus x1. And the y1 and the x1 are 2 coordinates that are from a single point on the line. And they already tell us they want it to go through point W. So I'm going to replace the y1 and the x1 with this right here. So this has an x value of 1, and y value of 5. So then I can say y minus, and then what's my y1? 5 equals I'm going to leave that m blank. I'm going to calculate that. X minus, what's my x1 is 1. And so they all have that. Okay. So then I guess the real work here is to find the slope. Well, let's find the slope. I've got 2 points given to me right here. Okay. So I've got a -5, -2, and then way up there, I've got a 5, 6. So I can use my uh, slope equation here, change in y over the change in x. Right, so as long as we just identify what's my x1 and y1, and we keep them consistent, it doesn't matter which set is x1 and y1, which set is x2 and y2. So my y2 is 6, my y1 is -2. I'm going to end up adding those. And my x2 is 5, and my x1 is -5. Once again, I'm going to end up adding those. I end up getting 8 over 10, which is 4/5. Now, some of you were able to do that without the calculation. You could do the rise over run, or we could notice that, hey, look, this y-intercept looked like it's hitting right on the integer. So let's check it. 1, 2, 3, 4. Okay, that's my rise. And then my run, 1, 2, 3, 4, 5. And there we go. I've got my 4 over 5, and then it does the same thing again. 1, 2, 3, 4. 1, 2, 3, 4, 5. We could have done it all in one big jump. It would have been 8 over 10. We would have had to simplify. So then our answer is B, because that's the only one that's got the 4/5. They all have a 4 and a 5, but they've got them in different positions and different signs. So how did we do here? Well, we had 50% of our students get this correct. So not the worst, but definitely not the best. We had 20% choose C, right? So at that point, wrong sign, and the numerator and denominator are flipped. And honestly, if they weren't guessing, this could be the perpendicular slope. So there could be some students out there that remember something special happens when you're looking at parallel slopes, perpendicular slopes. Perpendicular slopes are the negative inverse. And so we could have had some students tripped up by that. Parallel slopes are identical. So that's a possibility. And we've got 17% that chose D. That's just the reciprocal slope, and then 13% choose A. And so that's just the sign error right there. But overall, this was on the more difficult side. This was tied for the 21st hardest item on the test. That 50% is not very good. Next, for 29, we are looking at parent functions. We don't have anything graphed for us this time. This is standard A.7c. And this is one which we can graph to help us, but we can also do this without graphing. All right, so if we think of parent functions, we need to think of g of x equals a f of x minus c, right, plus d. It's these three terms, the a, the c, and the d that do things, okay? A is a term that stretches or narrows the width of a graph. C is what happens left to right, so I'll just put these arrows here horizontal. D is what happens up and down. It's a vertical shift. So when we're looking at x squared for quadratic, and then we have an x plus 7.2, we're simply dealing with this right here, okay? So we're going left to right. But it is f of x minus c, okay? So if I wanted to translate that into an f of x plus 7.2, what am I going to need to do? Well, I'm going to need to go f of x minus and then negative 7.2. Those two would end up turning into my plus 7.2. That's the tricky part about this. So I have a negative 7.2 shift, and this is horizontal. So I'm going to the left, which means my x value, right, is going to end up being negative 7.2. And my y value is still going to be, at this point, when we're looking at just the basic vanilla function, f of x equals x squared, the vertex is at the origin. So we're still staying on the x-axis. We're just shifting it 7.2 units to the left. Okay, so here's my answer. Now, we did all of that work without graphing any of this. We can graph this. There's just one minor thing that we need to keep in mind. Let's bring it over here. Let's do Desmos. Okay, so if I just do f of x, right, and if I just try to type that in, remember, this is a parent-child function, okay? So this f of x plus 7.2 is actually needing to go right inside here, okay? So that x of 7.2 plus 7.2 needs to be squared for it to show up. So I'll just use y here equals, and then what I want to do is I want to parentheses x plus 7.2. Right now it's a line. So I know it's a quadratic. That's why we have to square it. Okay? So if we square it, we'll notice that my point right there is negative 7.2 comma 0. So if we put it in there, we need to make sure we square it to make it a quadratic. So that's another way to double check our work as well. So our answer is B. Now how did we do here? Well, we had 41% of our students get this correct, so that is pretty low. 41%, definitely not at that threshold we're looking for at 60%. Now, interestingly enough, 32% chose C, and hopefully uh, you see the reality there is students were thinking, since first off it's positive, they were thinking it needed to go to the positive, but take a look, 0.7.2, if I'm looking at that, 0.7.2, that's a vertical shift. So we had a lot of students think that this position was going to get you a vertical shift because probably in a lot of our practice problems, that vertical shift, which is in this D position, is probably the most common that we deal with. And so first off, thinking that a plus 7.2 is going to move you to the negative is counterintuitive. And then when it's inside the parentheses, we need to know it's a horizontal shift, not necessarily a vertical shift. And so we had a vertical translation up for 32%. That was our most chosen incorrect answer. We also had 18%. Now, this is still dealing with the horizontal shift, but this is thinking that the plus 7.2 moves you to the right. Interestingly enough, that wasn't the most chosen incorrect answer. C was. And so that lets us know that the misconception is not so much what do you do with an x minus c? The misconception is which one of these moves up and which one of these moves side to side. And so students really need to focus on memorizing this sequence right here and knowing the difference between an A, a C, and a D, because if they know that, then this x plus 7.2, f of x plus 7.2 within the parentheses becomes fairly easy, but they have to memorize that form with all of the terms. And this was our 13th hardest item on the test, or tied for our 13th hardest item on the test. So 40%, definitely not what we were looking for here. The lack of visual made it a challenge for many students, no doubt. For number 30, we have an inline choice here, and we're dealing with rate of change. This is A.3b, and we have a problem situation and a table. So we have an altitude of an airplane, right? And take a look. It's not graphed, but as the x goes to the right, the altitude drops. So if we were to graph this, okay, you notice we get like a 1.5, 3.25, 6. And obviously we can put this into Desmos if we really wanted to graph this. I just want to make this real quick. Take a look at this. It starts up here at like 25, then it goes down here to 20, then it goes down here to 12. So we have a descending aircraft right here. And so that's going to help us. It's as the x increases, the y decreases. And so that's actually our first statement. What is happening to the altitude? The altitude is the y value. Well, the y value is decreasing. It's 25,000, 20,000, 12,000. So we need decreases. Now, at the rate of, now we need to calculate the rate. Okay, well, our rate is the same thing we've been using, right? Let's do the change in y over the change in x. So let's just pick two values. Okay, so let's just pick those two right there. And we need to clarify which one's going to be which. Let's make that x1, y1. And let's make that x2 and y2. And let's cut out the middleman here. Let's just put a calculator on for this. That's going to be helpful. All right, so my numerator is going to be 20,250 minus 25,500 over, and then I need my x2, 3.25 minus 1.5, and that is going to give me a negative value because it is a negative slope. It is descending at 3,000 feet per minute. Now, those are just the two values I chose. If you wanted to double check, or if you wanted to make this your x2 and this your x1, this your y2 and this your y1, you'd get the same thing. That's the whole idea behind the rate, is that when it's constant, it doesn't matter what your x and y values are. So we are going to say 3,000, and then that is our correct answer. Decreases at 3,000 feet per minute. Now, how did we do on this one? This is a 2-point problem. So the students that got both items correct was 43%. Not horrible. It's the one item correct that makes this a much easier problem. We had 47%, because honestly, you had a 50-50 chance here. So you had decreases or increases. Most students could see that the altitude was decreasing. So even if they didn't want to calculate, they can hit the decreases. And then if they got the other one wrong, at least they got partial credit. So we're looking at 24% of the 47 when we're looking at percentage correct. We take half the 1 point. So you're looking at about 67% mastery. So well above that 60% threshold. So we would say that we're doing pretty well on this one. We had only 10% of students unable to get any points. So that's not bad. This was tied for our 7th easiest item on the test. So we should be feeling pretty good with this item. Even though it was a tag enhanced, it did not necessarily throw our students off too much. For number 31, we are solving quadratic equations. This is A.8a. Now we need to find solutions. When we're thinking of solutions, we might be thinking, all right, well, let's use the quadratic formula, which we can, but quadratic formula works when we have ax squared plus bx plus c. I don't necessarily have it in that form, right? This is an expression that I need to multiply out. So if I really wanted to, I could FOIL out the 5x plus 3x plus 3, multiply all that, bring the 75 over, get an a and a b and a c. I could do that. But there is an easier way. So let me show you. So if I want to get the x by itself, obviously, right? So I could take both sides, divide both sides by 5. But what that's going to do is that's going to leave me with simply an x plus 3 squared on one side. 75 divided by 5 is 15. Now at this point, my x plus 3 is wrapped up in that squared, so I need to take the root of both sides. Okay, so the square root of that squared is going to cancel out. So I'm going to end up with x plus 3 equals square root of 15. There's no way to simplify that. We'll just leave it like that. And we start to see the square root of 15 in our answers. And then all I need to do is bring that 3 over. So I'm going to subtract 3 from both sides. And I get x equals, at this point, before we plug that in, right, we're going to take that and we're going to put the plus minus. It's going to be negative 3 plus or minus square root of 15. So our answer there is D. Like I said, if we wanted to FOIL this out, we could have done the quadratic formula. We would have ended up with the same thing. But there are other ways to solve quadratic equations. Especially look to see if they give you a term with a square on the outside, is there a possibility of taking a square root and saving yourself a whole lot of trouble? So the answer is D. Now let's see how we did. And this was 30%. This was definitely difficult for our students. In fact, take a look. We had 25% here. We had 27% here. So almost as many students chose A or B as they did D. 17% here, which lets me know that we are, as a state, guessing. And that is because a lot of our students that they will either complete the square, or they will use the quadratic formula, or they will factor. All of that depends on having an expression on one side of the equation that fits this form. When you don't have that, you have to work to get it back there. And so if students were trying to use an a squared plus b, ax squared plus bx plus c with this, the a and the b and the c are going to be off. They're not going to be the correct values, which means they ended up with wrong answers and they ended up guessing. So we need to help our students also practice what happens when you can take the square root of solving quadratic equations. Fortunately, that's not going to necessarily be here, right? All we have is the quadratic formula, so that's not one of the options that's listed on the reference materials, but we need to help them practice. It's not used as much. Typically, you can just complete the square or factor, use the quadratic formula, but sometimes the best solution is to use square roots. This is the third hardest item on the test, and for the most part, it is very close to just guessing. And once you see that, it becomes a pretty simple problem. You notice I didn't have to really do any calculations. I didn't need to open up my calculator at all. It's a recognition first that makes it a challenge. For number 32, we are looking at quadratic domain and range. This is A.6a. And as you can see, we have part of a quadratic function, but domain and range is the same for quadratics, linear equations, exponential functions. Doesn't really matter. We need to understand what is the difference between the domain, what is the difference between the range. Okay, so let's define both, because if we don't know that, then we are just going to be guessing here. And in order for us to know what the domain is, we need to know what the range is, because those are two separate things. Okay, so these are the set of all independent variable values. We've been working with independent and dependent variable values since the 6th grade. In short terms, these are the x coordinates. Okay, so when we're talking about dependent variables, that's what we're looking at for the range. So the range is the set of all dependent variable values, or in layman's terms, we're going to call those our y-coordinates. Okay, so when we're looking at our domain, we're looking at the x-coordinates. We're looking side to side. First off, we need to notice that we have circles here, so it's going to be greater than or equal to, less than or equal to, because we are including those two values. So it's going to be, in terms of x, I'm going to show it with symbols first, and then we'll translate that into words. So x is greater than or equal to, and what is this value right here? Okay, I've got a -2. And x is less than or equal to, what is this value right here? It's right on that line, 3. So that's what I'm looking for. X is greater than or equal to -2, and I don't even need the 3, because look, there's only one of these that has the correct lower bound. So there we go. That's my answer, D. And how did we do on this? Not as good as you would think. 45% of our students got D correct. It's a little bit of a surprise there. 24% chose B, right? So this 1 and 3, so maybe they were just looking at 3. And notice what 1 and 3 is. 1 and 3, those are the x-intercepts. So you could have some students out there with a misconception that domain equals the x-intercepts. They're the x-coordinates, but not the x-intercepts. You also had 23% of our students choose A, and hopefully you can see that that's the common misconception. That's the range. So this basic idea of what is the domain, what is the range. And the domain is the same whether it's linear, whether it's a quadratic, whether it is an exponential function. Still tripping students up. We had 7% choose C, and that's just all the x values that you see on the graphs, -6 to 6. So this was difficult. We still need to go back to domain and range. This was the 18th hardest item on the test, and quite honestly, shouldn't have been that difficult because it is more of a recognition and interpretation than an actual calculation. Number 33, we are looking at the laws of exponents. This is A.11b. We have an expression here that we need to simplify. And let's go ahead and open up our reference materials because those are always available for these laws of exponents. Very helpful, so we can just keep it right there. All right, so what I want to do is I'm going to deal with the bases, okay? So I'm going to take this expression right here, and I'm going to separate it. I'm going to put my constants together, and you can do this, right? You can separate this. I'm going to do my k to the 9 over k to the 3. Because remember, when you multiply fractions, you just multiply top and bottom straight across. So if I were to multiply this back, I would get back to what I want to. So being able to separate these becomes extremely helpful because now I can deal with each one separately, right? So what is 16 over 4? Well, that's 4. What is k over k to the 9 over k to the 3? Okay, so let's look at that. That is going to be when you're dividing here, right? That is going to be your quotient of powers. So a to the m, I'll put that over here, over a to the n equals a to the, and then you end up subtracting the 2, okay? So then I'm going to put this down here. So k to the 9 over k to the 3 is going to end up being k to the 9 minus 3. So that's going to end up being k to the 6. Okay, so I'm going to put a k to the 6 right here. And then I've got the same thing, m to the 7 over m to the 14. I end up subtracting. So m to the 7 minus 14. So that's going to end up being m to the negative 7. Now, how do we properly display that is we need to have this negative exponent, right? If it's a negative exponent, it's 1 over. So really that's 1 over m to the 7. Okay, so we can do 1 over m to the 7. Well, if we view all of these as over 1, now I can multiply straight across, and I can get 4k to the 6 over, the only thing in my denominator is m to the 7. And so that is my answer, B. So how did we do here? Well, we had 52% of our students get this correct, so not quite at that threshold of 60%, but also not bad. So we had 20% choose A, right? And so we actually did pretty good. Look at this. K to the 6 over m to the 7, k to the 6 over m to the 7. What did they do wrong? They subtracted the coefficients. They did 16 minus 4 gets you 12 rather than 16 divided by 4 gets you 4. So other than that, they were good. We had 15% choose C. So they had, once again, they messed up on this coefficient here, and then they ended up dividing rather than subtracting the exponents, right? This was 9 divided by 3 gets you 3. This was 14 divided by 7, even though it was backwards, gets you that 2. And then we had only 13% get D. Same mistake here with the exponents, though they did get that coefficient correct. So this was the 23rd hardest item. So on a 50-item test, right close to the middle of the test. 23rd hardest item on the test. This just takes extra practice, and honestly, we need to have those reference materials up all the time. For number 34, we are looking at zeros of quadratic functions. This is A.7b, and they give it give us the zeros and kind of the answer form, and they want us to go backwards, which is kind of different than what we're used to. Okay, so what we're used to is we are used to getting something like x plus something times x plus something equals 0, right? That's what we're looking for in the factored form. And then we can set each of those to 0. We can find the values. So we need to find what these two terms are, and these two terms are going to be two of our answers right there, okay? So what they tell us this is h and then of negative 3 halves equals 0, and then h of 5 equals 0. So that says that x equals, then I can take this negative 3 halves, and then x equals 5. Okay, so those are my two zeros, negative 3 halves and 5, because when you plug those in, you get 0 and 0. Well, how do I turn this back into this? Well, remember when we were to take something like this, if I were to take an x plus something, you'd have to subtract that factor from both sides to get it equal to 0. So if I want to turn this into this, I need to get this negative 3 halves and the 5 back over on the correct side with the x. So let me show you what I'm talking about. X equals negative 3 halves. Well, I need to add 3 halves to both sides. When I get that, I get x plus 3 halves equals 0. Okay? Same with the 5. X equals 5. I need to subtract 5 from both sides. So now I get x minus 5 equals 0. Okay? So then I can say my answer could be x plus 3 halves, x minus 5 equals 0. And then that would get me these two values right here. Because if I wanted to figure this one out, I would say x minus 5 equals 0, add 5 to both sides, and I'm back to where I started. X equals 5, which is this right here. So I could do my x minus 5, but you notice I don't have a 3 halves anywhere. Well, another choice for this one would be if I were to do x plus 3 halves. If I really don't want a denominator there, I could multiply the whole expression by 2 and then distribute this in. So this would end up being 2x plus, what's 3 halves times 2? The 2's would cancel each other out. 2x plus 3. So 2x plus 3, and then x minus 5, that's going to equal 0. That's what I'm looking at right here. It doesn't matter the order in which you put it in. Okay, so we are going to get our 2x plus 3. So I'll put that first. If you put it second, that is also fine. The order doesn't necessarily matter on this. And this is how we get 2 points. Now, as you can probably surmise, this was a difficult item. Very difficult. 17% of our students were able to get this correct, both points. We had 36% of our students able to get at least one of these correct, which means you put 18 plus it there. You're looking at 35% mastery. Really, really low. 46% of our students got no points. And so this was definitely challenging. This was tied for our 7th most difficult item on the test. And quite honestly, I think it's most likely because we started with the zeros and we want the students to work backwards into factored form. We don't do that very often. We will give you the standard form, the ax squared plus bx plus c, and then ask you to find the factors. So this gives us another opportunity as educators to help our students go from the actual zeros back into factored form. And that's just an extra skill that we can help our students develop. For number 35, we are looking at adding and subtracting polynomials. This is standard A.10a. So we need to add and subtract these polynomials. They give us a problem asking about the perimeter of this triangle, but really we just need to take these three expressions and we need to add them. So let's think 3 halves x plus 5/6. That's one expression. Let's do the 3x minus 1/6. That's the second expression. and then the 2x plus 1/3. So let's take all of our x's and bring them together. So what are we going to have? We're going to have our 3/2 x plus 3x plus 2x. Now let's take our constants, bring them together. 5/6. I've got a minus 1/6, and I've got a plus 1/3. All right, so these two become 5x's. This is really 1.5 x's. But since you notice that I've got everything here as an improper fraction, what I want to do is I want to convert this into a fraction with a denominator of 2 so I can easily add this. So I'm going to say this is equivalent to 10/2. Right, I just multiplied top and bottom. So this is 5/1. Multiply top and bottom by 2, so I end up getting 10/2 x plus my 3/2 x. That's going to end up being 13/2 x. That just saves me from having to convert a little bit later. And then I've got a 5/6 minus 1/6. Well, that's easy. That's 4/6. 4/6 plus this 1/3. Well, different denominators, but if I can reimagine that 1/3 as a 2/6 just by doubling it, you notice I've got a 4/6 and a 2/6. If I add 4/6 and 2/6, I get 6/6 or 1. So I get my 13/2 x plus my 1, and that is my answer, C. How we did across the state of Texas? Well, we had 47% of our students get this one correct. And our answer choices, look at our answer choices. For the incorrect answer, 17%, 17%, 18%. So definitely these three are guessing. They're not necessarily making a mistake. We're just guessing one of these. And then obviously there's going to be some students piled in here that just guessed and they guessed correctly. So this is definitely one in which we want to work with our students. This was the 20th hardest item on the test. I don't think the challenge was necessarily grouping the like terms. I think the challenge is, how do you add 3/2 plus 5? Because that's really what this is. 3/2 plus 5. Even if you can do that, even if you change the 3/2 into 1.5 plus 5, you got a 6.5. 6.5 doesn't exist. I need to convert this back into my 13/2. So this goes back to basic middle school adding positive rational numbers, in which we are adding mixed numbers. We're adding fractions. Same with this. This 4/6 plus 1/3. That's just basic adding fractions, knowing that you can't add two fractions with different denominators. And these fractions are not necessarily easy to plug into the calculator. They are repeating decimals, so you couldn't just plug it in unless you put them in that fractional form. So this was definitely a challenge for students, and I think it was more of the basic operations rather than the understanding of adding and subtracting like terms. For number 36, we are writing linear equations. This is standard 8.2c. And we have the cost y for x tickets. I'm just going to make a little table here. They're already defining the variables within the first few words here. So x tickets, y cost. Let's use this to kind of organize what we have. We have a flat processing fee. So when we have a flat processing fee, that means it's a constant, not tied to a variable, which means I'm thinking it's going to be slope-intercept form there. It's not necessarily going to be direct variation. So we can probably already get rid of A and B. And then we got a cost per ticket plus that flat fee. So we've got 4 tickets for $160. We get 8 tickets for $300. Right? So if I'm looking at a linear equation, right, I either have two choices. I've got my direct variation, which it's not going to work because it has a flat fee. So we need slope-intercept form. And let's look at our slope. Our slope is going to be the change in y over the change in x. And so let's see what we've got here. So we've got difference of 140, a difference of 4. So that's going to be 140 over 4. And that's going to be 70 over 2. That's going to equal 35. 5. Okay, so $35 per ticket. Now that's the only 35 we have, but if we want to, we can plug in two values to figure out what that B is. So let's plug in these two values. Let's say 160 equals 35, right, times 4 plus B, and that's going to be 160 equals 140 plus B, so that B is going to equal that 20. So that is our correct answer of C. Now, how did we do? Well, we had 53% of our students get this correct, so a little bit more than half of our students were able to successfully navigate that. We had 20% choose A. So they chose the direct variation, right? And if you just take your 160 divided by 4, then it's going to be 40. The problem is that doesn't work for this. 300 divided by 8 is not going to equal that 40, right? You would need 320 divided by that 8 to get that 40. So that's not going to work. 16% gets this, which is the other one. This is what 300 divided by 8 equals, that 37.5. So these two are direct variation, but they only work for one or the other. And then we had 11% choose D. You notice we've got the right values, 20 and 35. 20 and 35, they just switched the slope and the y-intercept. So this was kind of right in the middle, 24th hardest, or tied for the 24th hardest item on the test. So kind of right in the middle there. And this is just a matter of recognizing that when we have a flat phi, that means we are going to have a y-intercept. We're going to have a constant outside of that variable. For number 37, we are factoring trinomials. This is a.10e. And so we've got a few options here. We can complete the square. We can use the quadratic formula. This is a pretty simple quadratic expression here. So I just want to do factoring. And really what I'm thinking is, what are two numbers that multiply to my c term if I'm looking at ax squared plus bx plus c, right? Two numbers that multiply to c and add to b. So let's look at our factors here of 30. And it's going to be negative 30, which means one factor needs to be positive, one needs to be negative. Since I'm adding to a positive, I'm going to make the smaller factor negative, the larger factor positive, because I want it to end as a positive. So let's do negative 1 and 30. That's going to get me to 29. So that's not going to get me there if I added those two. And let's do negative 2 and 15. They multiply to negative 30, but they get me to 13. Let's do negative 3 and 10. That's going to give me negative 30, and that gets me to 7. So there we go. So what would get me to that 7? Well, I could do an x minus 3, x plus 10. That would get me to this expression right here. So we only need one of them. You notice there's no x plus 10, there's only an x minus 10. So our answer here is D, x minus 3. Now, that might seem simple, but a lot of times when we get this, we'll get both factors, and we can either factor ourselves, or we can just use the distributive property and FOIL to find the answer. In this case, we only have one factor, so we can't just plug and play. We have to actually do the work. And this ended up being on the harder side. 40% of our students were able to get this correct. And we had 26% of our students get B. Now you see we have the 10 and the 3, but that negative 10 wouldn't work with a positive 3. That would get us a minus 7. And then we had 16% and 17%. So the 15 and the 5, I mean 15 times 2, 5 times 6, but those are all individual factors of 30, but they wouldn't work with anything else to get to that positive 7. So this was definitely difficult. In fact, this seemingly simple problem was tied for the 11th hardest item on the test. So when we are working with trinomials, we need to have students just factor and eliminate all answer choices. Don't let them cheat by looking at the answers and just multiplying the answers out to finding one that matches the expression. Just cover up your answers and just let them factor from scratch, and that will be as close as we can to mimicking what we're seeing here on STAAR. Next, for number 38, we are looking at graph transformations, and we see we've got inline choice, so a graph of G is either going to be less steep or steeper, and then the y-intercept is going to be less than, same as, or greater than. All right, so we've got just a basic linear transformation here, because we've got f of x equals x, so this is standard 8.3e, and it's transformed to look at this. Okay, so I can tell you what's going on here. When we have this term right here, what that does is that is going to affect the slope. Okay, so if your basic f of x is right here through the origin, okay, so this is f of x. So let's look at what's going to happen here. First off, it's going to be a shallower slope because that fraction is going to go up 1 over 2, up 1 over 2, rather than up 1 over 1. And we're going to have a y-intercept of 3. So it's going to go a little bit higher, and it's going to be less steep. So it's going to look something like that. Now, you don't have to take my word for it. Let's graph this. And let's just put it in Desmos here. And let's just do y equals x, right? That's going to be our basic vanilla function. And then let's look at y equals, and let's just do 0.5x plus 3. All right, so you notice that it's shallower and it has that y-intercept of 3. So that matches what we were looking at here. So the graph of G, that newer one, is less steep, and the y-intercept is at 3, but we just need to say, is it less than, greater than, or the same as that of f? F has a y-intercept at 0, goes to the origin, so it's going to be greater than. And so that is going to be our answer. 2-point problem of less steep than and greater than. Now, how did we do across the state of Texas? Well, we did fairly well. It's a 2-point problem. And so we had 44% of our students get both points correct. 1 point was 38. So if you take half of that 38, that's 19. And if you add that 19 to the 44, you're looking at 63%. So mastery. So we're over that threshold of 60% that we're looking for. We had 18% get 0%, get nothing. And that's saying something, because it's only a 50% chance of getting that one right. You've got a 33% chance of getting that right if we're simply guessing, right? So if we want to calculate the probability there, it's not out of this world just to at least guess one of these correct. Okay. For number 39, we are looking at standard 8.2i. We are writing systems of equations, and we're used to writing systems of equations, but you notice that we have a graph and we have a table. Typically, we're going to get 2 tables, we're going to get 2 graphs, or we might get a verbal description. But in this case, we've got to do one of each, and I don't know which one is which. And take a look. All of our answer choices here are in standard form. Okay, so I'm going to calculate the slope, and I'll use the slope-intercept form, but then I'm going to need to convert that into standard form. So let's start with this line right here. Okay, so I can tell you that lines can be a little bit easier because I have the y-intercept of -2, and look at my slope. Okay, change in y is 1, 2, 3, and then change in x is 1, so 3 over 1. So I can say this is y equals my slope of 3x, and then it's -2. Now, I need to turn this into standard form, and I want my x to be positive, which means I'm actually going to subtract y from both sides. So I would get 3x minus y minus 2, and then I want to get that 2 over here. So it's going to get 2 equals 3x minus y. So 3x minus y equals 2. I see that right here. I see that right here. All right, so let's look at my line P. Now, I do have the y-intercept. I don't need to calculate that because if x is 0, where is it crossing the y-axis? It's going to cross at 4. So let's look at that same thing. Okay, so let's look at my change in y. My y is actually decreasing 2 while increasing 1 on the x-axis. So it's actually sloping down, which means it's going to be a negative 2 slope. So y equals negative 2x plus my 4. And I want my x to be positive, so in this case, I can actually add 2x to both sides. I get 2x plus y equals 4. And so it looks like we're going to get that one right up there because this has got that 2 in front of the y instead of the x. So my answer here is A. And as you might have surmised, that one was difficult. 32% got this correct. Now let's look at the other ones. 34%, slightly more, got B. And you see how it's close, right? Obviously, they got the table correctly. It was the switching from this right here. They got this on the line, and then they ended up adding 3x to both sides to get this 3x plus y. They didn't have to do all this rigmarole that I did down here. They just added 3x to both sides to get that x over on the left, but adding 3x to the right side would get you 6x. It wouldn't eliminate the x, so that's not going to help. C, 20%, and then D is 14%. So if you added these two together, that's 66%. That means 66% of our students were able to get line P and had a pretty good idea as to what's going on with this first line, line N. The challenge here is what happens when you get this in slope-intercept form, and you have to change that into standard form. You don't want that x to be negative. So that's the work, not necessarily generating slope-intercept form, is translating from slope-intercept form to standard form. And so that's where some of our students might need some extra practice. This is the fourth hardest item on the test. And the issue wasn't with writing the systems of linear equations, it was just changing it from one form, slope-intercept form, to another form, standard form. For number 40, we need to find which function is equivalent here. We are writing quadratic equations. This is A.6b. And so we have just this basic form here, and what we want to do is we want to put this into standard form. All right, well, let's just look to see what does x minus 3 expression squared actually mean. Well, that means we're going to take this. I'm just going to write it twice because that's what that means. X minus 3 twice plus 5. Okay, so now I can use FOIL here, right? So I'm going to do the first. Still that 4 needs to sit on the outside, okay? X squared, and then the outer minus 3x, inner minus 3x, last, and that's going to be plus 9 plus 5. So I need to distribute this 4 out to all of those terms. I'm going to go ahead and make this a minus 6x. So I can take the parentheses off. 4x squared. 4 times minus 6 is going to be minus 24x. 4 times positive 9 is going to be a plus 36 plus 5. Let's make that plus 41. So I'm going to get f of x equals 4x squared minus 24x plus 41. And so we see our answer there of C. And we actually did fairly well on this. We just basically needed to apply the distributive property there once we wrote that x minus 3 squared into x minus 3 times x minus 3. 64% of our students were able to get this correct. So that's above that threshold. We should be feeling pretty good about that. We had 16% choose B, and that's where they squared each term in x minus 3 rather than using FOIL. We had 11% choose A and 9% choose D, so we're getting close to that statistical noise right there. This was pretty easy. In fact, this was tied for our 10th easiest item on the test. For number 41, we are graphing inequalities. This is standard A.3D, and we simply have an equation here, or an inequality to be more specific, and we need to graph it. Now, it is an inequality, which means we need to pay attention to the sign, because that's going to direct which way the shading is, either at the top, like it is for A and B, or below for C and D, and then whether it's a solid line or a dashed line. So we could go ahead and identify a few things right away. First, it is a greater than or equal to. So greater than or equal to, that equal to right there, whether it's greater than or equal to or less than or equal to, both of those mean we have a solid line. So we could go ahead and I'll write over here A, B, C, D. We can go ahead and eliminate B because it is a dashed line. And we could eliminate C, or we can eliminate D because it is a dashed line. So there's only two lines that we need to look at, A and C. And notice that they all have the exact same graph. Have you noticed that? They've got a y-intercept of 1 and an x-intercept of 2. And then we go down the same thing. And then we do the same thing for C and the same thing for D. So we don't even necessarily need to calculate this particular inequality and figure anything out. We're just trying to identify what's happening with the symbol. So it is a solid line and it is greater than. So greater than means it's going to be above the line, which means we can choose A. Now, if we want, right, we can choose a value that is in A just to verify. So let's just, or in the space above, let's just choose 3, 3. So 3 plus 2 times 3 is greater than or equal to 2. So 3 plus 6 is greater than or equal to 2. 9 is greater than or equal to 2. Yeah, so shading above is definitely going to work. All right, so there's our answer, A. Now, how did we do? Well, we had 58% of our students get A, so that's pretty good. Almost at that threshold. We had 19% choose C. Now, that was the other greater than or equal to sign, which means it was the other graph that had the solid line rather than the dashed line. So that makes sense, as that is the most chosen incorrect answer. But right behind it was 15%. It was, so this one was really, if we're looking at B, was really focused on the greater than. And C was really focused on the equal to part of the inequality, and then you put those together, you get A greater than or equal to. And then D, we had 8%. So overall, this is pretty easy. In fact, this was tied for a 22nd easiest item on the test. So pretty good on that one. So next, we are looking at number 42. This is solving systems of equations, 8.5C. And so we have some equations right there, and we don't necessarily have to write them from problem situations. And so we've got a few different options here. We can change this second one into standard form and subtract the equations, elimination. We could also use substitution. Since it already says y equals, let's just substitute this in to that y right there. We could also graph. So let's see, 6x minus 2, and then I'm going to just put this whole thing right in there because that's what y equals. So that's 3x minus 5. Now we'll need to distribute that 2 out, equals 10. So I've got 6x minus, and then that's 6x. Okay, that's going to cancel each other out. minus 2 minus 5, that's going to be a plus 10 equals 10. So that cancels out, and I get a 10 equals 10. Now that is interesting. I don't get a y equals or an x equals. The x's just disappeared, okay? Which means something weird is happening. And if I don't know what to do next, let's go ahead and graph these. Now, I'm going to need to change this one into slope-intercept form to use the calculator on Cambium. So let's go ahead and do this, okay? So let's do 6x minus 2y equals 10. And then let's subtract 6x from both sides. Okay, so I've got negative 2y minus 6x plus 10. Divide each side by negative 2. And then I'm just going to get y equals, that's going to be 3x minus 5. Now that's interesting. Look at that. I just changed this into slope-intercept form, and I wanted to isolate the y, and guess what I got? Y equals 3x minus 5. Y equals 3x minus 5. It's the exact same. It's two different equations, right? So if I get a 3x minus 5, I'm going to get a y-intercept at minus 5, and it's going to have a slope of 3, rise of 1, right? Something like this, rise of 3, slope of 1. But both lines are going to be the exact same. So that if that means I've got both lines at the exact same, I'm going to layer this other line on top of it, which means I have infinitely many solutions. It's basically the exact same equation. You just doubled the second one, or the first one, and then you put it in a different form. You put it in a standard form rather than slope-intercept form. But if every single point on the line touches, that means it's infinitely many solutions. Our answer there is D. Now, that was a little bit challenging to understand because most of the time when we're talking about system of equations, we have to solve something and we have to use elimination or graphing or substitution, something. I only had 38% of our students to get this one correct. So 38% of our students were able to get that. And look at this, 24% no solutions. So that's the other one that lets you know that, something weird is happening. 23% chose B, and then 14% chose A. Now here's the thing. -1, -8 works, but so does 3, 4. So some students just plug this in, saw it as an answer, said, all right, that's good. But they didn't try the other one. If you get 2 correct answers, then you should be thinking something strange is happening. So this was the 9th hardest item on the test. This was the first time that this particular standard has asked a question, and the answer was infinite many solutions. It's been an answer selection once, but never been the actual answer. So that was a challenge for students. Next, for number 43, we are writing exponential functions. This is A.9c, and we have an equation editor. So we have just a basic setup for an exponential function, a little bit of a story problem. We need to know that we are dealing with our exponential functions, right? So our function beep for number 43, we are looking at writing exponential functions. This is standard 8.9c. And so what we need to think of is what our standard form for exponential functions is. So that's going to be y equals a times b to the x. We've got a little bit of a story problem here, and we're going to need to type this into the actual equation editor. And so what are our terms here? Well, our A is always our initial or our starting amount. So what are we starting with? If we ever deal with compound interest, it's the principal. It's always the beginning population if we're dealing with, growth rates of population. So in this case, it's just the 500. So y equals, our initial amount is 500. Now our B is our rate. And it's always 1 plus whatever that percentage is. If it's a growth rate, 1 minus the percentage. If it is a decay rate, in this case, it is a growth rate, 2%. So it's going to be 1 plus 2%, so 0.02, or we can just imagine that as 1.02. And then you raise it to the x power, and that's just your time, x years, but we leave that in x because that's our variable. So it seems pretty simple. Y equals 500 times, and then 1.02 to the x power. But this equation editor is a little bit wonky. So the 500 is pretty easy. I'm going to open my parentheses. I'm going to type in 1 point, not that button, that is a dash. So that's a negative if we needed that. 0.2. But if I hit the parentheses again, watch, it's going to open up another parentheses. So that's not what I want. So it's not super intuitive. What I need to do is I need to hit the arrow button, or you can click on the screen, go on the outside of the parentheses, and you notice that the closed parentheses is now light gray. And once I hit something else, it's going to actually close the parentheses. So now I need to hit my exponent, and I've closed, my cursor is shifted up, and I've closed the parentheses, and I'm going to raise it to the x power. So that is the correct answer, but we had to kind of navigate that parentheses. As you could expect, it wasn't super difficult to set up the equation. The hard part was the tag-enhanced item using the equation editor. And this had 20% correct. It's 1 point, either correct or incorrect. Even though it's tag-enhanced, it's only 1 point item. This was our first hardest item on the test. And I would think a lot of students that struggled did not struggle with setting this up. They struggled with this. So we need practice on these practice exams using the equation editor feature on Cambium, especially using parentheses, using exponents. You kind of had to navigate it because if we're on calculators, typically you'll see it like this, y to the x. So this doesn't necessarily mean the same thing. So if we're using calculators all the time, like Inspires, TI-84s, we just need to know that it's going to look different on different calculators. Number 44, we are identifying functions. This is A.12a, and we need to just remember the basic definition of a function. So y is a function of x. That means that each input, so our input is going to be our x values, has only one output. Our output is going to be our set of y values. So each x leads to one y. So look at A. I've got -2, -2. So I've got the same x, but it leads to two different y's. It leads to a -4 and a 4. So that's not going to work. For B, it's pretty easy. I can just do a vertical line test. And if I can draw a vertical line and it hits the graph twice, it is not a function because I've got the same x with two different y's. That's not going to work. Look at x. Here, I've got a -4, my x is -1, my x is 2, my x is 6. 4 different x's. They can end up leading to the same y if we need to, as long as the same x doesn't lead to different y's. And so this is going to be our answer because this does not pass the vertical line test either. So our answer here is C. And we did fairly well on that one. We had 62% get the correct answer, so that's above our threshold of 60%. We had 20% choose A, probably because B and D were immediately eliminated because of the vertical line test, though that's obviously not helpful when you're looking at a table of values or even a mapping. So the vertical line test is only helpful when you graph it. So overall, we did fairly well. This was pretty easy. This was our 14th easiest item on the test. And so we should feel pretty good about that one. Number 45, we are looking at solutions for systems of equations. This is A.3f. And we have a function here that represents the first of two systems equations in a system of linear equations. And the second equation, we don't even know. It just simply says the second equation has a different slope. What does that mean if it has a different slope? Okay, so I can roughly graph this. If this is y equals mx plus b, there's my 8. I can get a point there, right? And then if it's got a slope of -4, it's down 4 over 1. So I can do this. I can do this. Okay, so this is my first line. All right, let's pretend that goes through that line right there. All I know is it has a different slope. Well, it doesn't matter what that different slope is. At any point, if it's on the same plane, it will intersect. But how many times will it intersect and have a solution? No time, one time, two time, or infinite. Well, it's not infinite because if it has the exact same slope, it has infinite solutions, right? This has a different slope. If it's an identical slope, if it's the identical equation, it's going to have infinite solutions. If it's an identical slope, but it's a different equation, then it's going to be a parallel with no solutions, right? But if you have a different slope, that means eventually somewhere it's going to intersect one time, and it's going to have B exactly one solution. So our answer there is B. We had only 50% of our students get this correct. Our most chosen incorrect answer was C. Exactly two solutions. Uh, Possibly thought that maybe the x and the y coordinates were two different solutions. Not sure where the two solutions come from. This is probably hard for students to visualize because they're so used to actually solving it, using graphing, using elimination, using substitution, just needing to describe it probably threw some of them off. So this was actually on the harder side. This was tied for our 21st hardest item on the test. And so instead of simply calculating, we also need to make sure our students have a deep conceptual understanding of it so they can describe it even when there's no visual and there's only one equation given. For number 46, we are looking at linear equations and the distributive property. This is A.5a. We've just got a little bit of algebra here to do because we need to solve for w, but we got w's all over the place. So using the distributive property, we need to take care of this. Let's look at this left side first. Minus 2 is on the outside of w minus 9, so I need to distribute this to both. So I'm going to bring that 7w back. Minus 2 times w is minus 2w. Minus 2 times minus 9 is a positive 18. Okay, let's do the same thing over here. 4 minus, let's make that an 8w plus 2. So I've got a 4. I'm going to distribute that minus 8 out. So minus 8w, then a minus 8 times a positive 2, it's going to be a minus 16. So I've only got one w on the left. I've got two w's that I can bring together. I can make that 5w plus 18 equals, I can do a 4 and a minus 16. 4 minus 16 is minus 12 minus 8w. All right, so let's now get the w's together. I want to add 8w to both sides. That's going to give me 13w plus 18 equals negative 12. And let's take away 18 from both sides. 13w equals negative 30. And then we can divide both sides by 13. It gets us this weird looking negative 30 over 13. But that is our answer, D. And so that was quite a bit of algebraic thinking here. We only had 41% of our students get that correct. So that ended up being fairly difficult. And if you look at our incorrect answer choices, I'll just write them in order here. 17%, 22%, 20%. Not really one that stuck out, which means if you didn't get it, you were probably just guessing. And there's probably a fair number of students that within that 41% on D also guessed and got it correct as well. So this was tied for our 13th most difficult item on the test, one in which we really need to spend a lot of practice distributing before we isolate the variable and solve. For number 47, we are looking at the difference of squares. This is a.10f. And so we've got to factor this quadratic here. So we could use the quadratic formula, but hopefully we notice that our standard form here is ax squared plus bx plus c, and we're missing an entire term. It goes 4x squared, and then we have a minus 81, but we are missing this middle term, right? The linear term that just has the x without any exponent on the outside there. So hopefully that makes us think, oh, that's kind of strange. If we look at our reference materials, we should notice that we have, up at the very top here, we've got perfect square trinomials. And take a look what we have, right? We've got the difference of squares. So I'm going to put this right here, a squared minus b squared equals, and then they go ahead and factor this out for us, a plus b. That matches what we're having here because this misses that middle term. So if we were to take a look at this right here, this 4x squared is my a squared. I have a minus, and I've got a b squared. Well, what could that b be? Well, that b could be, what is 81, right? If I take the square root of that, well, that's going to be 9. Okay, so I can say that b equals 9. And then if I could take the square root of the 4 and the x squared, right, I could say that a equals, well, the square root of 4 is 2, the square root of x squared is x. So then what I could do is I could just plug those in, and I can say it's 2x minus 9, and then 2x plus 9. Now, let's just verify. Let's FOIL this out. So I'm going to get 4x squared. I'm going to get a plus 18x. I'm going to get a minus 18x. So that's how you get rid of both of those, and then you get a minus 81. So we're back to where we started. So it's 2x minus 9, 2x plus 9. It doesn't really matter in which order you put these. It will accept either combination as to whichever one's first, and that is our answer. Now, how did we do? Well, this was on the easier side. Even though it was a drag and drop, and you just had to kind of find everything on your own, we had 40% of our students get both points on this. We had 37% get 1 point. So if we take half of that 37%, that's 19. We're looking at about 59%, so almost at that 60% threshold. And then we had 22% get 0 points. So this is all about recognizing, is this first a quadratic, and are we talking about perfect squares? Because if the first and the second term are perfect squares, we notice that there's no middle term, we should be thinking perfect squares. And this was on the easier side. This was tied for our 19th easiest item on the test. For number 48, we are evaluating functions. So this is standard A.12b, and it's pretty straightforward here. We have this function right here, and we need to find f of 4. So what that means is when we're thinking of this f of 4, this is a function of 4, we realize that the f of x and the f of 4, that x is being replaced by the 4, which means they're asking us what happens when x is 4. So we simply plug that back in. So f of 4, f of x, here's our standard, right? We're going to take this and we're just going to replace every x with 4. That's what f of 4 means. So 3, and then I'm going to take the x, replace it with 4, and that's it. So f of 4 equals 3 times 4 squared is 16, minus 7. I'm going to use my PEMDAS, the order of operations. I need to multiply first. Well, I had to square first, then multiply, then subtract. So f of 4 equals 3 times 16 is 48, minus 7. So f of 4 equals 41. And that's it. That's all we need to do. Our answer there is C, 41. So once we realize that that f of 4 means you put the 4 where the x is, it's simply order of operations. And we've been working on that since the 5th grade. So we had 57% of our students get this correct. So very close, but not quite at that 60% threshold. We had 20% of our students tripped up by B. And so the scary thing here is what happens is when we do the f of 4, this right here is where we ran into issues for B, is instead of squaring that 4 times 4 is a 4 times 2, and they made that 12, and then so that just kind of messed them up. And so that's something that we still need to work on with students. What happens when you take something to the power of 2, the power of 3, whatever that exponent is, does not mean multiply by 2 or 3. It means multiply that number by itself that many times. So this was our 24th easiest item on the test. So close to halfway and a little bit on the easier side than the harder side. For number 49, we are looking at 8.2a and we are evaluating functions. For number 49, we are looking at standard 8.2a. This is the domain and range of linear functions. And we are simply asked, what is the domain of this function? We have something graphed out here. We need to know the difference between the domain and the range. So the domain, the range are sometimes asked together for both, or the trick is which one is which. So this is the set of all input values. Now we can take a word input and we can replace with independent variable if we want to. And sometimes we just boil this down to our x values. So the domain are the x values, the input values, the independent variable values. Then the range would be output, or we can say dependent variable, or just in a pinch, y values. So x values. Look at this. We're going from 0 to 12. And that's it. Now, if we want to, we're going to have to show that with an expression here. It's an inequality. So 0 is, it's a filled-in circle. So we're going to say it's less than or equal to 12, because it's got the filled-in circle, which means it's going to be less than or equal to. We can include 12. And it's greater than or equal to 0. So there we go. Our answer's sitting right there. It is B. And if you're thinking that was easy, you are correct. That was fairly easy. How did we do, though? Well, we had 67% of our students get this, so 2 out of every 3. So that's good news. This was fairly straightforward. The domain was sitting right there in front of us. Now we had 17% of our students get tripped up by this. First off, they're calling for y, so that's not the domain, that's the range. At least they identified the range correctly, right? That's the 0 to 100. But 17% of our students still could not find the difference between the domain and the range. And that's always going to be an incorrect answer choice. And then we've got 7%, 9%, what these are. Those are just all of the possible values. 0 to 14 on the x-axis, 0 to 100 on the y-axis. So this was pretty easy. In fact, this was our 19th easiest item, our 9th easiest item on the test. So that was pretty easy for us. And we're going to end up with number 50, final item on the test. This is graphing functions and identifying features. Every kid dreams of getting a question like this. 8.3c, they get a graph, and it simply asks, what's the y-intercept? If they remember what y-intercept means, it's where the line crosses the y-axis. You cannot find an easier problem than this. Well, technically you could, because this wasn't the easiest item on the test. This was the second easiest item on the test. Our answer is A, -2. That is the y-intercept. There's not much thinking. It's just recognition there. 78% of our students were able to get that. We had 11% choose -3/2. That would be dividing the x-intercept by the y-intercept. Not sure why we would do that. And then 7%, 3% statistical noise. So this was fairly easy and a great problem to end the test on.